Let me repeat that again. So we are going to have the 6.x version of the Cisco ACI, Cisco APIC, and for the new joinee, and this APIC and this particular ACI version has feature. You do not need to have the physical APIC devices. You can have the APIC as a virtual APIC, and you can install that virtual APIC into the EXXI hypervisor as well as on the cloud. So that dependency has been removed from the Cisco ACI. You do not need to have the physical APIC connection or physical APIC. You do not need to purchase the Cisco physical APIC at all in a 6.x version. Below to 6.x version, if like suppose if you're having the 5.x version, or you have running the like 4.x version something, you need to have the physical APIC.
So, Vijay, we do
Mhm.
not need to configure the CIMC in that case. I mean, if we are
No,
installing the API on the ESXi.
yes, you do not need to do that. But
Okay, so
yeah,
yeah,
that's
please go ahead.
also cost saving, right? That's the reason this is the game changing product which Cisco is launching in 6.x version. You do not you have to you do not have to put a lot of effort to do that. So
So,
yeah,
this Epic can be installed on the ESXi. I mean,
yes,
this can be installed as an virtual machine or as an hypervisor.
as a virtual machine. If it is installing as a hypervisor, then you will not
Hmm.
install on the EXXI, right?
Okay. Huh. So we
EXXI is
will
itself is
use.
a
Okay,
hypervisor
okay, I got it. So we will be using this Epic as
as a
a. I
VM.
mean, we will as a VM. Okay.
Or else if you do not have the physical, you do not, if you have the private cloud, public cloud anywhere, you can install
Hmm.
this apics on a cloud as well.
And what is this IPN? I mean, this interport network. I mean,
Interport network, yes.
so is this a, I mean, switch or router or what
It's
is this
a
connection?
layer 3 device. It can be router, it can be switch. There are certain features need to be enabled on this device, like sub interface should be supporting, Jumbo MT should be supporting, your multicast should be supporting, OSPF should be supporting. If any device support this these 3 4 features, can be act as IP, whether it's a switch, whether it's a router. Okay, I come to that point. Why we need IPN here? Okay, currently I'm focusing on the setup of the leaf and spine, not on the IPN for now. I will let you know that when it is required IPN and what is the prerequisite and how we can configure that. We will walk through all these things. Okay, so let me log into here. So this is the version I have. So let's start. I can register the entire ACI. So there is a two way to initialize the ACI. Either we can do from the fabric and discover that entire leaf and spine, or I can do the quick start from the system itself. The moment I say click quick start, there is an option to all these things like ACI fabric setup. I click here, ACI fabric setup. All these leaf and spine discovery option will be showing. Like if I say fabric discovery, begin to here. You do not need to go to the access of fabric policy, fabric tab, then access pol inventory, then register all these things. You can do from here only. I say leaf one. Let me register quickly. Make sure that you need to have the unique node ID and unique name in the APIC to register this leaf and spine switches. Otherwise, they will be conflicting in the database. Discovery. Yeah, so we have now spine switch now. So if I say spine 201,
So, Vijay, do we have any OVF template for this Epic so that we can install on the virtual, I mean, on the
Yes,
local workstation or VMware
yes, you need to
workstation?
have the OBF template for this API. Yep.
Okay, so I mean, we would need to download it from the Cisco portal, or how it is?
Yes,
I
you
mean,
have to
if you have,
download.
you can.
You have to
Okay,
download from the Cisco as a Epic as a OBF template, and then deploy OBF template to the vCenter.
in the vCenter.
Yeah. Sorry, let me paste this link itself. So vCenter, when I say the vCenter, which is like again controller of the EXXI. If you do not have vCenter, you do not need to worry about that. You can deploy that without vCenter as well. But usually
I mean,
previously,
yeah, can we deploy it on the VMware workstation and just
oh
for the VMware
yes, I
workstation?
believe yeah, you can do that. Workstation, when you call that, that's for the testing and all, right in your laptop.
Mm-hmm.
So you
Yeah,
can do
yeah.
that. Even now, like without a 5.x version, you can deploy this this APIC in your workstation. You can do that. Okay. So if I go to the spine, yes, 02, spine 2, then leave 04, 3. So let me give you the example. Why is coming the three options here in the leave: regular leave, remote leave, and tier 2 leave. What is the meaning of tier 2 and remote leave? Remote leave means you have one small sites and you have just leave. That leaf is connecting to your main data centers. So even your sites, remote sites, can be controlled by the Cisco APIC and can be integrated with the Cisco ACI if you have the ACI image running on the leaf switches, and those ACI image or those switches are 9K devices. Okay, that's one of the things. What is the tier 2 switch? Tier 2 switch means, suppose you have a spine switch, and a spine switch minimum, what is the requirement for the spine switch to leaf switch? 40 gig interface, right? 40 gig fiber interface need to have that. And that 40 gig interface, suppose if you're purchasing the one device which has 48 1 gig interface and 4 10 gig interface and two 40 gig interface, and you do not have 40 gig interface SFP, and you just do not want to purchase that SFP because that SFP can be expensive for you, and you just want to utilize 10 gig interface for as a uplink, and for these 1 gig interface which are available 100 to 1 gig, uh, they do not need too much bandwidth to have in this particular switch. What you can do here is one leaf to another leaf. You can connect that leaf in a ACI via the leaf to leaf connectivity. You can do that. That's we call the tier 2 switch. Tier 2 switch. This is a tier 1 switch. When you leaf to leaf discovery, when you do that leaf to leaf discovery, that time you perform this kind of connectivity. Let me show that one design for you. Uh, just give me a second. Not this. Sorry. Okay, so this is a spine switch between spine to leaf. This is the 40 gig connectivity. Okay, when suppose if you have the leaf which do not need 40 gig connectivity, you can directly connect the 10 gig interface. 10 gig interface between leaf to leaf switches here, and you can discover you can manage this all these leaf switches via the APIC itself. So APIC will not treat these switches as separate. You have to tell the APIC these switches are the tier 2 switches. So APIC will push all the configuration to these all the devices and form the ISIS, BGP, and VXL connectivity between these devices to spine switch as well. Okay, that, and this switch has, this is the particular model which I am using. So it's not like all the devices support tier 1, tier 2 connectivity. Some of the devices supports tier 1, some of the devices supports tier 2 connectivity. Okay, but most of them you can use as a tier 2. This is to save that costing, and this mainly we use, suppose if you have a management switch, right? You are using one of the leaf switches for the management purpose, and management require well 100 MB to 1 gig connectivity. You do not need too much throughput, or you do not need to worry about that. Then you can just extend that one layer to connectivity. Oh, sorry, one 10 gig, do one or two 10 gig connectivity with the leaf switch. That's it. You do not need to purchase 40 gig interface, 40 gig SFPs, all these things, which will also cost saving for you. Okay, that's why we call that tier 2 connectivity here. Okay, this is fine. Let's go to the epic initialization, the basic interface of the Cisco epic. This is the dashboard of the Cisco epic.
Rajat, means remote leaf and tier 2 connectivity is the same
No,
because
tier
in
2
both
is
it is connected to the leaf, na? Leaf is connected to
no.
leaf.
So the no. So here the major difference is remote leaf going to come via the spine switch, via the spine switch. Okay, via the spine switch, discovery will be happen via the spine switch. Right here, discovery is happening via the leaf switch itself. There's a two different things. The remote leaf is discovering via the spine switch, via the IPN devices from remote location. They are not directly connected. These are the directly connected to the ACI fabric. Got my
Okay,
point?
means that remote leaf will be connected to uh, Epic directly, or no? I didn't get it. What is
No. So
remote leaf?
suppose if you have one site, once you have main data center in Bombay. This is the, suppose you have Yes Bank main data center, for example, right? And you have two sites, alpha, beta, gamma, for example, here.
Yeah, okay.
In alpha, you have installed two leaf switches, leaf 1, leaf 2, and they are connecting as a layer 3 OSPF. You do not have leaf which is connecting directly to your spine switches. It is coming via some intermittent switch, intermittent device, which we call that IPN, interport network device. When you discover these devices, these leaf switches in APIC, you have to say that this is the remote leaf. It means it is always coming via the third network. It's not directly connected to ACI spine switch. It is indirectly connected to ACI spine via some third device. But here in a tier 2 switch, you have directly connected devices with the leaf switch itself. It's a directly extension interface, extended interface.
Okay.
Okay? You have to
Hmm.
differentiate in an epic, because epic will have to prepare the configuration based on the configuration which you select. That epic create the templates based on that.
Okay.
Okay.
In case you have any diagram like you have shown this one, na, for the remote leaf, then
Yes,
do.
let me show that. The remote leaf concept. This is the remote leaf. These are some sites you have. This is the main data center you have. Okay. And these are the epics connected.
Okay.
You do not have any spine switch in remote device. You just have
Mhm.
the single leaf switch which is connecting to the IPN device, any routing device, L3 device, and that L3 is providing the OSPF routing, and they will be integrated with the spine and epic. Okay.
Okay.
For tier 2 switch, will directly connected to the leaf switch here.
So, Vijay, this pod 1 and pod 2 are part of the same, I mean the single cluster, single ACI fabric, or this is
Yeah, you can have the multiple scenario in ACI. Okay, I come to that. This is the, you can have the multi-port. This is, we call that multi-port, like we have in S-Band, multi-port scenario. Okay, when you have two ports connecting to each other using the same APIC cluster, we call that multi-port scenario. It means you have single plane of glass for the entire management.
then what is the significance? I mean, what is the advantage of using multiple
Yeah, I
ACI?
come to that. Okay, no worries. I will be covering the multi-port separate topic, so I don't want to take hijack the multi-port topics for now.
Okay. And
Okay.
Vijay, one more thing. In last class, you
Mhm.
used a document. I mean, well, so I
Pradeep, could
mean,
you
is it
please?
possible?
Your voice is low. I'm hardly
I'm
able to
saying,
hear.
yeah. Can you hear me?
I can hear you now.
Yeah. So I'm saying in last class, you have used a document while
Mhm.
teaching us. So I mean, is it possible if you can provide that document? I mean, it
Yes.
was a very well drafted document, so it will be very useful for us.
I will upload that. Please.
Okay.
In the same drive which I have shared, I will upload there.
Mm-hmm. Okay.
Okay, so let's walk through the Cisco UI interfaces. Okay, that's a major thing here. When you first time log in the Cisco Epic devices, what is the use of these tabs? Why we use these tabs, right? So let's walk through that first before we begin to understand anything else. Okay, let's start with the system tab.
Okay, sorry to interrupt you. Just one more question. That you said now that Epic can be used as a VM, means you don't need a physical Epic to be
Yes.
connected to spine, right?
Yeah.
So in will you explain it more in that
Okay, so this particular feature is supported on an ACI 6.x version. Okay, below to 6.x version, you cannot install that virtual API.
okay, yeah, that you told that below that you need a physically Epic. So,
But
Yes.
Vijay, in that case, do we have to check the compatibility of the and I mean the ACI iOS
So
which is
all the
used on the
ACI,
switches?
yeah, all the ACI switches should be running 15.x version, I think, or 16.x version.
So okay, so that will be supportable. I mean, if we use ACI on the virtual as a
Yes.
virtual machine.
Yes. And you need to have the layer 2 connect or layer 3 connectivity between the that your ACI leaf and spine or API to the API. Okay. Perhaps I can take session to explain that virtual epic and what is the role of that. And even we have ACI in Asia, we call that V port. And if you want me to explain that, I can explain that also. There is a concept called the cloud epic as well. Okay. So I can
mhm.
explain in a separate session to in covering those all these low level to advanced level, all this connectivity and how they
Yeah,
works with all these devices. I can do that.
yeah, yeah.
Okay,
That
okay.
would be great because
Okay.
anyhow, this ACI is. I mean, so this ACI OS can be installed on the cloud as well. I mean, the Azure or the
Yes.
AWS cloud.
Yes, you can do that. Not entire Asia, but Epic, you can do that.
Yeah, yeah, okay.
Yeah, we call it cloud Epic. Yeah.
Okay.
Okay. Let's start with the system tab. What all the things you can do under the system tab? Okay, so first thing is you can check the alert under this tab. What we are going to get, we have to check. We have option to check the alert. We can check the fault. We can check the user management tools. For example, let me walk through here. In the system tab, if you see that quick start, one option is coming quick start. Quick start means you can install, do the fabric setup. You can do the create the access policy, logical policies, inventory, all these things you can do from the shortcut key. This is the shortcut key of the ACI setup. For in the for under the this setup and these options, tenant and system, you will get two short keys. It means you do not need to click under the tab and tab. You have when you want to create the suppose you want to create one EPGs for the endpoint group. You do not need to create go under each tab and do all this connectivity setup on configuration setup, right? You can simply just click here, and from here itself you can create that configuration rather than going around and checking all these things. This is very useful tab. Second is the dashboard. In the dashboard, under the you will get the all the system health. Uh, when you call the system health, it will give you the overall ACI score for the up and running time. Suppose if you have any issue, ACI running since 8 months, right? For example, in 8 months, what was the consistent score for the Cisco ACI running there? So for example, there was some outage in last 1 month, right? And what date and what time outage was? Score will be like this. and whether that outage has been recovered. If that outage has been recovered, what time has been recovered. It will give you that all the entire ACI health fluctuation and the report or timestamp of the event. Okay. Second thing is here, you're gonna get the node health, your leaf and spine switches health. If there is any unhealthy device which are available in your infrastructure, you can get all the details from here. This is the logical configuration health. If you have multiple tenants available, it will give you the, all the health of that. Suppose if there is any EPGs, bogus EPG available, that EPG has no uh, static binding or static binding is wrong, all this health report will become under the tenant only. Then you have Epic Health. If you have the Epic controller, what is the Epic controller health? If those health are not fully fit, then you have to fix that issue. Okay. Then you have fault counts, and type of fault count, you will get that communications, configuration, environmental, operational. So these are the four type of fault count, which you can see that these are the some fault count by domain, like access domain, external domain, infra domain, management domain, security domain, tenant domain, app domain. These are all the things, and these are the some, like we have critical, we have major, we have minor, we have warning. There is four types of alert you can get here. How many criticals are there? Critical or major has to be fixed when you have in your infrastructure. If you're not fixing that major and critical issue, it means you may have the some uh, outage for in your infrastructure. Then you have controller section. In the controller section, you will get all the epic details, like all the epic cluster details, leaf and spine switches details. You do not have much, but only you can see that basic configuration of the Cisco ACI epic. Okay, what is the serial number of the epic? What is the IP address? And what all the interfaces are being used. If you want to check that epic utilization, suppose epic is very slow, you can check that what is the process running in the epic and what is the current response time of the Cisco epic. Is there any issue with the storage? Suppose you're creating a lot of backups in a epic, right? Lot of backup session you have creating in a change window. Suddenly what happens is after some times you will get either like unable to create the backup or unable to take the local backup on a Cisco API. It means the storage is totally full. You have to uh, free the storage from the API to in order to recreate the backup and in a local API. Okay, those all the things you can create here. And if you want to go to the system setting, under the system settings, there are a lot of features which are useful available, like Cisco connectivity preference by default is connecting to in-band. If you want to have passphrase based connectivity, suppose if you have cloud API, or if you want to create that authentication based API login, you can do using the passphrase, you can do that. This is the bridge domain setting, which we'll discuss. This is a route reflector from shortcut. You can create from here. You can change the MTU value for the leaf and spine. So the moment you will change the control plane MTU value, this will be reflecting on the MPBGP session between the leaf and spine switches. By default is a 9000, which is a recommended one. Do not try to change the 1500. This is COPP. There are two types of COPP. By default is compatible type, which is recommended one to keep that. But if you want to have the more secure infrastructure, you can create that strict type as, where you have to manually authenticate all the leaf and spine in order to make that compatibility in the infrastructure. This is a time zone where you can change the date, which is very important for the real-time events. If you're having ACI infrastructure, you make sure that you have proper time configure and NTP configure. If you do not have the NTP configure, then it's going to be hard to you for you to identify that event which is happening in your infrastructure. For example, downtime or any major or minor incident. You will be the time stamp will be totally different than the what you have in the infrastructure. Then you have endpoint controls, which we'll be discussing in the when we cover all the EPGs and all. So these are some endpoints detection timer, which you can modify that, but always recommended to keep that default values. Do not try to change that. This is the fabric security. If you want to do that, but do not try to do that. This is a fabric wide setting, where you have a lot of options to modify your infrastructure behavior, which we'll discuss in a bit. Like if you want to check disable the remote endpoint learning, if you want to enable the enforcement VLAN validation, if you want to enable the off-flex client authentication, if you want to change that SSL certification, if you want to change the SSL certificate for the leaf and spine connectivity, all these things you can do that. Okay. And this is the like global AES again for the APIC authentication. So if you want to do that, you can do that, but it's not majorly used in the infrastructure. This is the global endpoint policies, which you can create like in a micro segmentation, which is not for currently in use. I will discuss that. This is the ISIS policy. You can do load balancing between the leaf and spine. By default, all the leaf spine does the load balancing. So the traditional method which we use, when you call the traditional method, it's a round robin. It means we have leaf and spine switch, and these leaf and spine switches are load balancing. Like suppose for example, sometime going to here, sometime going to here for the same host. Okay, so it's a round robin currently is set up, which is we call the traditional load balancing. If you want to modify that load balancing, there is an option you can do that, aggressive and conservative. Okay, which is not recommended. So again, there are use cases for those things, which I've covered that. Nexus cloud, Nexus dashboard connectivity, I will discuss in a multi-port scenario. This is port tracking. If you have port tracking, which is legacy port tracking for the leaf and spine switches port, you can do that. You not need to worry about that. PTP here, quota. These are the like port redundancy policy. Then you have alias if you want to create. Suppose, for example, if you want to create a peak one, and if you want to write any banner, you can write that. So the moment you will write the banner, you will, if you try to log in through CLI, you will see that particular banner. In a legacy environment, you have to type a bunch of command to enable this kind of feature, right? But here it's very, very easy. If you want to enable the banner for the Cisco APIC, you can do that. If you want to enable for Cisco Leaf, you can do that. If I save that, you will see that APIC name will be changing here. I change here, okay? Look here, APIC one is coming now. So similarly, if you have multiple sites, you can define that each site with a different APIC cluster name. Suppose, for example, this is the Bombay site, you can say the Bombay. If you have this a Hyderabad site, you can say H by D. Similarly, kind by. So it will be easy for you to identify based on the name itself. This is the multicast. This is a system performance by default frequency which we have. So this is like the major part is router reflector, control plane MTUs, endpoint security, fabric wide security. These are the some major components which which will be used in a real time infrastructure, and you have to be very careful while checking that system setting, because most of the things will be you can find here only. There is a smart license options. If you have any license in your infrastructure, you have to connect by default. All the Nexus product come with the evaluation license of the 120 days, 120 days evaluation license. Even ACI come with the evaluation license, and all the features you can enable in ACI with the evaluation license. You do not need to have that advantage or essential license to have that Cisco ACI up and running. No, you can start the Cisco ACI without having any license, and you can configure entire ACI without any license. Later, you can install that license. So one is the like you upload from CLI. One second is you can upload from here only. You can upload from here only. Second option is to having a smart license. What the smart license means? So Cisco introduce one cloud. Cisco introduce one cloud, which has one licensing server. Cisco say that no problem. Whatever I'm selling to you, I am going to take all these devices serial number and I will put in my cloud server, license cloud server. You just have to make sure that your APIC device is reachable to my cloud server. I will upload all these license and I will sync that all these license in your Epic. It's a cloud-based license. The disadvantage here is if this connectivity loss after a few hours, there is some downtime for that. You will be having an issue like either it will be showing that license which you have connectivity is lost, and you have to fix that in a critical issues. That's a one way, which is most of the customer nowadays is going with, because it won't take too much price to sync that global database, and it's easy to manage that, right? Because you just, if you're purchasing a new Cisco device, you do not need to worry about that license installation and all this. Cisco say that I'm going to provide you centralized database which has all the license. One thing you have to do, you have to make sure that Cisco license website should be reachable to your device. Rest authentication and all you can do from the Cisco Smart Licensing also. You can configure here. Yeah, this is website which should be reachable from your Epic with the 443 ports. If this website is unable to reach to from the Epic to the Cisco cloud, then it's not going to be synced. Okay. If you have a smart license on-prem, if you want to create that, you can do that. Somewhere you, yeah.
So if this cloud is not reachable from the ACI fabric, so in that case, what will happen? I mean, the services will
In
be
this
down,
case,
or
so you will not lose connectivity entirely. You, because ACI Epic will be downloading all the Epic will be downloaded all the uh, required licensing. The only thing is if you're adding a new leaf and spine switch, that time your Epic will not be able to register that those devices under this latest license which are available in the cloud.
But it will not go down, means the existing
No,
service will be running.
yes, it won't be.
so,
It will be non-service disruptive.
so
Okay.
you mean to say that the same certification or the same licensing will be available on the Epic database as well?
Yes, it will be, because it eventually all these servers, that's safety of the licensing safety. Okay, when you have the cloud Epic,
Hmm.
so all the latest image which are available, which has been registered here, should be downloaded here, because eventually Epic is the one who is going to distribute all these licenses to the leaf and spine switches via the in-band interface.
So in that case, we have the redundancy.
Yes. So even if you lose the connectivity, the only thing is if you are adding a new device, that device license won't be syncing from the here. And if you're having a like expiry date of the licensing, you will not get the notification from the any email alert. The here is main advantage is centralized manage. You do not need to worry about anything. Cisco will automatically send you message like your license is pending or expiring within 120 days or 10 days or 20 days. This kind of message to keep sending. And the second thing is you do not need to manually upload this license. Suppose if you have 100 device, right, in your infrastructure, you do not need to manually upload 100 device license to here. You just simply just add all the devices here with the serial number, which Cisco by default add here when you purchase a smart licensing sales team. You just have to authenticate that license with your connectivity. That's it. Or else, if you do not want to use Cisco on a smart license or centralized license solution, you can deploy your own services on your data center on premises. But if you do not want to use that anyone, use the offline license. Offline license means manually you can upload that license in your Epic devices. Okay. This is saying that look here, smart license, suppose connectivity is not there. This is the error is showing that. A smart license is disconnected, saying that. Okay, saying the severity one. Occurrence one time, and this is something happening, but it won't have any downtime at all. Okay. It means this connectivity is totally lost. You will get all the events of that. Okay. If I acknowledge that, there might be like configuration required, which I don't have it here. Okay. Here. You have to put the product token ID, which is like Epic token ID. And the moment you will put that, it will automatically go to the database of the smart license. It will sync that information. This is all the process how you can go like each and every process Cisco provides you one guide to perform that all the process. So do not need to worry about that. Okay. Second is fault options. Here in the fault option, you will get that all the real-time data. When I say the real-time data, suppose if you're having a port downtime, port flapping, all these kind of things will be reported under the fault, where you will get all the event, four types of data: operational data, environment data, config data, and communication data. Communication data means your access policies, your physical interfaces are down. Operational data means your protocol is down. Your configuration means you have something wrong with your external connectivity. If you're having an environmental means if you're having any PDUs or physical devices, high CPU utilization or memories getting full, this all kind of information will be under the environmental data. So there are like four types of fault tolerance data which will be available here. Okay. In the history, what exactly you're going to get here is, in history, you will get all these fault history with the code, with the warning, with all these threshold, with all these effective area, which is again enhancement of the fault. It was not there in an early, like early version of the ACI. The later version of the ACI, they have introduced like within the 24 hours, how many faults have been delayed, introduced. Within 1 month, how many faults have been introduced, and what exactly was the impact of that fault. Okay, if you want to have the event log, you will see that. If you want to see the audit logs, you will see that who modified that. If you want to check, suppose there is some activities happening in your infrastructure and you do not know what is going on, right? You will directly come to the audit log and you will get that, okay, this particular user has modified this particular services, saying that if created or modified. This is the user ID. And this is the timing which has been modified. Suppose if there is any outage happening in your infrastructure, the first thing is you have to do here is come to the fault or audit logs, check that what exactly is happening. The good part here is no one can delete the audit log. Even if someone try to mess with the APIC, no one can delete the audit log from UI interface, whether they have admin access or not. You have to access APIC through the SCP, then you have to modify the APIC event logs file in order to get rid of this. Otherwise, without acknowledging, without solving this, the error won't be go away. Okay. Then we will get that how many sessions is activated here currently, and what all the users has been logged into this particular device. Then health records, you will get that all the health record of the events which are happening. If you see that configure zone, again, this is like, if you want to divide your leaf and spine into the multiple zone based settings, you can do that, but it's not really good to have that. But some of the scenario is good to have the zone based configuration, which I will be covering that. No worries. Then is active session means you're gonna have the how many users are currently active, including the remote users and local users. Then a security, if there is any security which are currently configured, like contract and on all these things, you will be directly seeing from here. Second is tenant. So in the under the tenant, all the logical configuration of the ACI will be done under the tenants. All the configuration will be done via the tenant. So by default, there will be the three default tenant, common tenant, infra tenant, and management tenants. What are the use cases I will be covering in the tenant section. Okay. All the, let me draw that one topology here for you to understand that. So this is the leaf and spine, right? So below to this one, call that tenant. Logical configuration you do on top of this leaf and spine switches. Then here we call that access policy. Access policy. When you call access policy, it means you are configuring the physical interface configurations, like such as layer 2 protocol, layer 1 connectivity will be always come under the access policies, fabric policies. Tenant means you have all the logical configuration on this. Suppose, for example, VRF creation, subnet creation, or for example, routing creation, all these things will be under the tenant. Okay. Let me go to the again. Under the fabric policy, you will see that three options are coming. Inventory, fabric policy, access policy. What is the fabric policy, access policy? Difference here is, the major difference here is when you have the two types of connectivity in ACI by default. Two types of
Vijay,
connectivity.
tenant, there is only one option present for showing us the detail of the tenant.
Right?
Okay, this is okay. You will explain it when we will configure it, right?
Yes. Yeah, this is like
Okay.
all the tenants. This is what is available currently. And I will be explaining in depth these things. Okay, no worries.
Okay.
This is all the logical level configuration you have to do from here. This is like access policy. When you have leaf and spine connectivity, this is the spine, this is the leaf, for example, and this is connectivity. When you configure the any host-based configuration, like suppose there is one server connected, right? One external device is connected, router connected. This we call that access policy. It means any connectivity which is towards the server, which is towards the any external device, we call that under the access policy. If you want to create the any layer 2 speed, VLAN, CDP, LLDP should be enabled. All these things we will be configuring under the access policy. What is the fabric policy means? Any configuration between the leaf and spine. Call that fabric policies. Under the fabric policy, we configure all the policy between the leaf and spine. Suppose if you want to change anything between this interface to this interface, you have to come under the access fabric policy. This means this is the fabric policy. We are configuring the entire fabric, not the access policy, not the in-host connect devices. What is the inventory here? And then if I show you that in access policy, we'll see like this. If you see fabric policy, it will be like this. So all the tabs will be same, except the use cases for these two policy will be different. The inventory tab, in the inventory tab, you will get that multiple option. If you want to configure the multi-port, multi-site, if you want to register your nodes, if you want to check the duplicacy of your any IP address, all these things will be come under the inventory. It means the topology tables, all these inventory tables will be come under the fabric inventory tab here. This is just to manage your entire ACI setup. How many node pending? How many nodes are pending? How many unreachable nodes are available? Is there any firmware which is set to auto upgrade? All these things can be done. Like if there is any duplicacy in your infrastructure for the IP, you will be seeing under this inventory tab. Okay, what is the error which is coming here? That's fine. Then in the virtual networking, all these, if suppose if you want to integrate VMware hypervisor with your Cisco ACI, if you want to,
Hello, Vijay.
yeah,
Sorry for disturb. Can you just go back to Fabric? Actually,
yeah,
there is one tab, Pod One. Now, in my organization, we have used the two pods, Pod One,
two
Pod Two.
ports. Yeah, you have
Yeah.
multi-port.
So can we means that both the pods will be communicate between the or
Yeah,
means
you need to have the spine to spine connectivity in order to make that. That we call that multi-port. Multi-port. It means you have single cluster which is managing two different ACI
means
fabrics.
Pod One, Pod Two will be different.
Different,
That's right.
yes, they are different. Yeah,
They will be not communicated between the
they
both.
will be communicating via the spine to spine.
Okay, okay.
Okay, that's we call that multi-port scenario. When you have a spine connectivity with the one, when you two location try to communicate as a stretch fabric, right? Suppose you
Actually, in a
have
single, in a same location, we have advertised the means we have to create the multi-pod because all the leaves will be full on my pod one. So we extend that.
Okay, I got that. So you have one data center where all the leaves are getting full. So you are creating another data center port.
Yes, yes.
Okay. Then each port will be having their own spine switches. Okay. They can be same location, they can be different location, but cluster will be the same. AP cluster will be the same across the site. So from single interface, you can manage both the data center.
Okay. Got it.
Okay. I come to that when I cover the multi-port, all this scenario. That's no worry about that. I will be coming there. So in Cisco ACI, the very
Just in that case, the epic will be like if we are using three epic in our data center, the epic count will be the same. The spine will be in one side it is if two spine and other is two spine, then we are introducing two more spine and then they will connect to the same epic, but it will work as port 2.
yes. So
Okay.
either you can have the, let's suppose if you have three epics, you can deploy two epics here, one epic here, and
Hmm.
form the cluster. If you have five epic, you can deploy three epic here, two epic here, and form the clusters. Spine and
We
leaf
have
epic.
deployed the 5 epic.
Hmm.
3 epic will be pod 1 and 2 epic
Yeah.
will be the pod 2.
Yes, that's where you can do that.
Yeah.
And these epic to epic will be communicating via this link, via the spine.
Okay.
Okay, like this one. Suppose this is the connectivity you have, I believe. Yeah, this is connectivity you have. You have, for example, three epic, for example, five epic, right? So you have two ports, port one, port two, and they are communicating via the some third devices, which is called the IP and interport network device. That device will be providing the layer 3 connectivity between the two data centers. And all the advantage of using multi-port here is you're going to have stretch services. If we are creating the VLAN here, VLAN 10, that VLAN 10 will be available here and here, both data centers. It will be like active data center. Okay, if you're creating the bridge domain 10.1.1.1, that bridge domain will be stretched across the two sides 10.1.1.1. Either this leaf can use this bridge domain, any leaf from this port can use this particular bridge domain. It's like global
Means we can
configuration.
use the EPG or BD also for the both.
Yes. Come again?
Means when we have some advertise like we have create the BD or if the we can create the EPG on pod 1, so we can use that in pod 2 also.
Yes. It's in a multi-port scenario, there is no such call that only for the port 1 configuration, okay, except the layer 3 out. Whatever you're going to create, it's going to be visible across the two ports. It's up to you whether you want to utilize that or not. Okay, if you are creating the
Understand.
bridge domain won't be available only for the port 1. It will be visible for the across the port because you have single cluster, right? Single cluster means this bridge domain will be available for both the ports. If you want to utilize both the, in the, suppose if you have database services, DB1 here and DB1 is here, DB2 is here, and you want to have that active data center database or active standby database, you can use the same bridge domain across the two sides for high availability purpose. Okay, no worries. I come to that point. Okay, in a step by step. No worries about that. I covering that points I have in my mind. All these things for the virtual networking. Suppose if you have VMware integration, you always come to the virtual networking. You have to integrate your VMware with the Epic under the VMM tab, which we call the VMM domain, right? That's come under the virtual networking. If you have anything related to the hypervisor, whether it's a Microsoft hypervisor, whether it's your Red Hat hypervisor, OpenSite, Shift hypervisor, OpenStack hypervisor, Kubernetes, Microsoft, VMware, SDN, all these things can be integrated with the Cisco ACI under the virtual networking tab, just to make sure that. Okay. What is the admin tab means? In admin tab, you have multiple options. If you want to configure the TechX, Radius, AAA authentications, you have to come under this. What is the then under the admin tab, you have multiple options which are available, like scheduler, firmware, external data collection, configuration, rollback, import, export. So any kind of backup, dynamic backup you want to create or scheduler backup you want to create, you have to come under the admin tab. If you want to upgrade any your ACI, you have to come under the firmware tab. If you want to create any uh, external data collection policy, suppose if you have the syslog, SNMP servers which are trying to get that information from the Epic or try to integrate with the Epic for the logs and all, you can get from the external data collection. If you want to have the config rollback and creation, suppose if you are doing some activity, always you create the backup from here. Suppose for example backup, I created one snapshot here. Location is here. It should be Successful created. If I see that successful created, you must be seeing here. Let me show that.
It will take some
Yeah,
time.
yeah, here is created. Suppose if you want, you have created, you have one change, right? And existing configuration was right. The moment you did some changes, there was some issue, right? Immediately you can compare that to configuration and you can roll back even. So suppose let me create test 2. It's taking time. No worries. Successfully created. So if I go here, this is two configuration, right? You can compare this one configuration with this snapshot of the second. You can roll back immediately. This roll back. So you can compare the configuration as well as you can roll back and you can import export the configuration. This is from the local tab, as well as if you have some remote FTP, TFTP server, you can configure that. I come to that, okay? When I will cover that tab.
Means by selecting the last backup and selecting the rollback, it will automatically get whatever changes I have done under that particular change, it will get
Revert back.
mm.
Yeah,
But
it will
there is
revert
any
back.
effect, means any like
No, it won't take downtime for you. No worries. It will just override the policy. So you might see the some flapping for like less than 30 second flapping. For
Okay.
the excess
Means
means
load, you can use.
there is no outage when
There
the
is no
production
outage.
hours.
That the policy which will be, suppose you created one tenant one here, right? And you have not created tenant one in a backup one, right? So only tenant one, the policy will be overridden and rest policy will be remain same. So it won't be the create having any kind of outage in the
Okay.
rollback. Then import export policy, again, this will suppose you want to create the schedulers, rollback policies, export policy. Suppose if you want to have the tech support, if you want to generate, you have to come under the admin export import. You can create the on-demand tech support here for the leaf and spine switches. And can we create tag here? If you want to create on-demand tag, you can get it from here. If you have any remote destination, you can import, or you have to create that tag support in the local database of the Cisco API. Then you have to export that from here to your local PCs. Then if you want to check the core file, suppose your one of the leaf is rebooted and generated the core file. Most of the time you will find the core file here. If you do not want, you do not have that, you can create that core file from here itself. Then this is the remote location, all these things I will be covering. Okay, this all these things, this is just an overview of that. Then come to the operational tab. Suppose if you want to get the troubleshooting of the source and destination, you can search that one source EPG, destination layer 3 out or EPG. You can create the one session. It will give you the exact topology from which interface of the ACI is coming, which interface is going out. And if there is any issue, or suppose packet is dropping because of some ACI problem, it will give you the entire picture of the Cisco ACI and give you that exact presentation. You can do even the trace route. You can do the even some kind of uh, contact visualization as well here. For the compatibility dashboard, this will show that how much your ACI is capable of, how many bridge domains
uh,
you can
Vijay,
create.
Vijay, can you go back to visibility and troubleshooting? In this, we can trace route from here, right?
Yeah, you can do that. Yeah. So the moment you will say that target and destination, and the put that submit here button, submit button here. So in that case, immediately your ACI will give that multiple option: atomic counter, trace route, contract, drop. All these options will be coming. If you want to do trace route, you can click on trace route, provide the source port, destination port. It will start the trace route for you.
Means like where like I have to enter the target means source IP and destination IP in the destination. Then what next action need to be taken?
Yes.
Submit.
So submit here. The moment you will submit here, so it will give you the leaf and spine design here. Like from this interface, this traffic is going to this interface, right? Source and destination. And we will give you that multiple options. Whether you want to trace route between them, you can say that, okay, I want to click trace route. It will ask you certain information like port details and all the details, session details. You will take the UDP, I want a TCP, something. It will immediately initiate the traffic.
Okay. Means like
I will show you in the after configuration.
how I will provide port detail.
So you know that these two hosts, source and destinations, are communicating, right? If they are communicating, there must be source and destination port number, right? That's what
Faridhi,
Uh-huh.
we get.
it's like you have to use the CLI. You can
Uh,
show endpoint IP, and then you can select that there is a VLAN interface which be created on that. Same like you have to use. You can take your endpoint in search. You can search. You have to all the information in below, just like that.
So suppose if
means
I type here phone.1.1.1, for example, right? If you have 10.1.1 available in your any tenant,
mm,
it will give you that here like this. This is the particular
mm,
EPG, this is the path, this is the 10.1.1 available.
mm,
Similarly for destination, if your IP is from the outside like 192.168.1.1, if the IP is available in your database, then it
mm,
will give you that options. Okay, select that. If IP is not for me, these IPs are not available, right? That's why
mm.
saying that nothing coming here.
Okay.
And then you have to select that session type here. If two hosts, suppose you are tracing between the two servers, then endpoint to endpoint, EPG to EPG. If you are tracing from EPG to external, like from layer
Okay.
3 out, then you have to select that layer 3 out. Then if you are tracing from external layer 3 out to endpoint, then you have to select that. If you are tracing from external layer 3 out, external layer 3 out, which is transiting via the ACI, you can trace from here. There are multiple options for that.
Okay.
I will show you that in a real session, I believe. I will get the lab.
Okay. Yeah,
Okay.
Mahesh, you were saying that we do the trace route in
Yes,
the
we can do that.
CLI. Yeah, regarding that, I'm asking like if we have more shortcut to that we can get and direct trace route here. Is
Yeah,
it possible? That's why.
when you log the session on that, there is a
Mm-hmm.
multiple options. Like you can check the any drops between the source to destination in
Mm-hmm.
that particular. You can check all the things in the GUI. When when you have used the CLI, you can check the ping and trace out on the CLI also. So it is better to you can use that for the troubleshooting GUI.
I will show you the no worries. Okay, I will show that then only your doubt will be clear. I believe when I will configure that my tenants, I will get the some in host, and those in host I can check that in a source and destination. I will show that what all the options are for troubleshooting. Okay, no worries about that. For the dashboard capability, suppose if you are running the 5.x version, your capability will be totally different. So for example, in my 6.x version, I have 3 epics saying that you have 3,000 tenants you can create. Out of 3,000, 3 is created. I have capability to create 15,000 bridge domain, 4 is created. I have capability to onboard 80 switches, which is like currently 4 switches are onboarded. 4 is 2 is fine, 2 leaf switches are onboarded. So like it will give you the entire fabric dashboard for the capability perspective, which is really good. Really good.
Which is
Suppose if you
that how many we have used, I mean, how can we use like it also give us the pending number, right?
no, it won't give you the pending number here, saying that this is the capacity of your entire fabric with the 3 epic. This is what you have so far.
Okay.
If
Okay.
anything is pending, it won't show here
Okay.
until unless
Okay.
you register that.
Got it.
Okay. If you have like
It will
10,000
give.
in, sorry,
Capacity it will give.
to give you the overall capability of your entire ACI.
Okay.
Okay, this much VRF you can create, and out of this much VRF, this much is already created. Less than 1% is utilized. Similarly, for the virtualization, service graph, hypervisor, how many integrated, all these things. Then it will come with the leaf capability. Suppose if you have leaf 1, leaf 2, something, what is the capability of that particular leaf? You can figure out from here. This is the capability of the entire fabric. This is the capability of the particular leaf. It currently is not showing because of virtual. In the physical, you will say that if you're having a 93, 180 FX, Then it will give that this particular leaf has this much capability, this much it can have onboard VRF, bridge domain, EPGs, MAC address, TCAM, VLAN, all these things. If you're having a 9348, it will give you that switch capability. Per leaf basis, per device basis capability, you can check here. This is for entire data center, entire ACI fabric capability, right? Suppose one of the leaf is overutilizing. How are you going to check that? You can simply come here on the UI interface and check that. Rather than going to the CLI interface checking, like running the show environment health, you can check that here. Third is the EP tracer. Suppose if you have 100 VLANs, 100 endpoints available in your database, and you do not know where they are configured, simply you can put the MAC address or the IP address of the endpoints and search that, and you can relocate that, the location of the endpoints. Okay. There is a visualization for the your atomic counter for the troubleshooting and checking the latency for the leaf and spine. For the app integration in the app section, so you have multiple options for the app. When you have, suppose you have 100 EPGs and they are having a contract between them, right? It's nearly to impossible to check each and every contract with the API in the UI interface. It's going to be very difficult. Even in CLI interface, you have to do a lot of segment mapping to check there's all these things, right? Here you can immediately install one app contract visual. You can say that, okay, this much contract is available and these are the EPGs and how they are forming the contract. If same thing for the ELAM capture. Currently, how you perform the ELAM capture? Through the CLI, right? Through CLI, you run the bunch of 5 to 10 to 15 command to do that, capture that ELAM traffic, hardware level traffic. Similarly, you can install the one ELAM capture logs app. You immediately you can select the source switch, destination switch, source IP, destination IP. And it will give you that ELAM report for the your ELAM capture. So you do not. So currently you are underutilizing your entire fabric. The moment you integrate your multiple apps with that, you can ease your life for day-to-day operations. Suppose if you have the some F5 integrated with your fabric or firewall are integrated in a fabric, how are you going to check that? You can integrate one simple F5 tools here application, and that application will give you all the health report, all these things for the troubleshooting. Is it chargeable? No. Cisco app can download from anywhere. So like I said, CIE.
Sorry to interrupt. Can we capture from source server to leaf?
Source server to leaf. You can do the
Yeah.
span. Yep, remote span. You can do that.
Vision means we have to install an application for that to do that.
Yes. For the UI interface, there is a two option. Either you can do that. APIC has certain limitation. Okay. APIC has certain limitations. If you want to do that by the APIC, go to the CLI. You will get the better options for the troubleshooting. Yeah. But in UI interface, there are certain limitation in that. You can check the fault and all, but you cannot generate that troubleshooting events. Suppose ELAM capture, span capture. Can you do that from APIC UI interface? No, you cannot do that, right? You can just create the policies and you have to export that policy to your desktop. Then you have to open your WARSAC. Then you have to check all these logs, right? But in Cisco APIC, Cisco say that no problem. If you want to get that inside dashboard details also, I am ready to integrate, give you that external tools app to integrate with your APIC ACI, and you can generate the reports. You look here, pre-upgrade validation. So currently, how we do that pre-upgrade validation through manually CLI and all these things, right? The moment you install this pre-upgrade validation, it will give you all the reports. It will generate one report for you and give you the one report saying that if you are going to upgrade the ACI, this will be the disruptive. This particular services will be non-disruptive. This particular EPG will be disruptive. This particular EPG is going to be non-disruptive. All these things will be giving options.
So how do we integrate this app with the ACI?
You can simply download from here. Okay, you can download from here from Cisco account, and you can upload it to here. You can upload it to here somewhere. Download, add applications. Look here. Here you can upload from your desktop. Okay, here I don't have currently, but you can just download and upload to the Epic, and make sure that the one disadvantage I see that these app tools are very huge. So if we are planning to install that, make sure that you have enough space in your Epic to upload that. Okay, so sorry, at center. Uploading the app tools. Just you can do that testing in a Cisco lab itself, rather than in your testing environment. In your production environment, you can have the like testing environment where you can get this kind of lab for integration and all. I will try to get that one lab for you, and I will show that one of the two ELAM capture, and I think contact where I can show that options I can get that. Okay. Suppose if you generated some report from the applications, you can easily download from that report from here. Okay. Then integration part. Suppose if you have UCS, UCS is running or SD-WAN is running.
Vijay, sorry to interrupt you. This is regarding something capacity dashboard. Any option to download the capacity report of that particular Epic, like sorry, particular fabric?
No, I don't see option, to be honest here. If you see that.
Because we need this capacity report everyone, so we need to note down every each and manually or any Excel file download here to share the capacity report.
Currently, I don't see that options. If there is any option like to generate the file from CLI, I can check that. Okay, but so
Okay,
far no. If there is any, I have no idea. But here is we don't have any option to initiate that. So two things. So when you prepare the reports, always make sure that you also capture the border leaf, the border leaf capability also, capacity also. Click on the leaf capacity, select that particular leaf device, and check that, because most of the times only specific device is overutilized, not the entire fabric. In my so far experience.
okay.
But yeah, for that generation, file generation, no, I don't see here. But yeah, I will check that, as I said.
Okay.
Okay. In the integration sections, so in the integration sections, you can integrate your UCS, Cisco UCS, UCSM with the fabric, as well as Cisco SD-WAN with the fabric, UV manager and the Cisco UCS manager. But you will not be able to perform the configuration changes, anything. This is just for the integration sake of integration. Cisco may enhance in the future to performing any kind of activity with that. But currently, for now, no, it's not too much you can do that. This is just for the integration, nothing else. Now,
You said UCS means integration of what?
UCSM, UCS manager, or Hyperflex, which is currently in use. You can do that integration with the Cisco ACI. Okay. Now let's go to the before I start the fabric policies.
Apps also fault option is there. So it is for what then?
Which
In
fault?
Apps.
In our apps. Okay, so if there is any app related issue happen, suppose you are installing one app and that app related issues happening, you will get here faults.
Okay.
Okay, that's totally related to the applications.
Okay. And can you go to operation again? One operation. Yeah. Okay. In this like visualization,
Okay, so you suppose you have the issue with between, you want to check that latency between the leaf and spine switches. Okay. Or spine to spine switches. This is the node 101, 102. You want to check that what is the limited latency of that. And if there is any packet drop, how many packets or drops are there? You can generate that report from this. Which we call the atomic counters to check the latency, to check that behavior, to check that the traffic flow between the leaf and spine. So this is totally for the fabric setup, whether your fabric is healthy or not. Suppose you troubleshooted everything and nothing, you see that any packet drop in a leaf or external device. So you obviously you check that between leaf and spine. Is there any packet drop? Is there any latency between? What is the latency of that? Is there device which are due to the overutilize creating the latency? You can check all these details from traffic type. You can drop packet. How many packets are receiving on the spine, which is between the leaf and spine? What is the packet uh, uh, sent details? All these details you can capture from.
Vijay, but I think it will be covered when we track the end-to-end source to destination trace route, right? There is no required to separately check the spine to leaf connectivity latency.
Yeah, but that for that you need to have that that will be totally between source and destination. Okay, latency between the leaf and spine switches, not the fabric latency. Fabric latency is totally different than the source and destination latency between the leaf and spine switches.
Because in end-to-end trace route, we got that hope which we have covered, right?
Okay, so there
So
is a two things: 10.1.1.1. 20.1.1.1. Okay, if you're tracing, doing the trace route from here to here, for example, right? In this case, definitely you can get the some sort of traffic latency, not the fabric. When I say the fabric latency, you will get the ISIS, BGP, VXLAN, COOP. This all the health check will be done in the visualization latency. This protocol latency. And when you are trying to trace route, it will be always use the overlay VXLAN trace. Tap to tap trace will happen here. So it will not give you that the leaf label, hardware label, but yeah, obviously you can get some idea, to be honest, from here. Okay. So let me draw one topology before we start that. So currently, I hope you have the this, how many tabs are there total, how many tabs we have in ACI? 1 2 3 4 5 6 7 8. What will be the major use of the Cisco ACI tab? This is the two app which 90% of the time we use that. You can see that this three app, not even this is the 5%, I would say that 90% of the time we use tenant and fabric for the ACI. One time, one of very less than 1% we use system tab for the configuration. For monitoring purpose, we always use the system tab. Okay, so the major part is to understand that how the ACI fabric works here. Suppose you have the, let's compare with the legacy environment. Suppose you have the one ports. Sorry, this is the one legacy environment. You have one access switch, which is catalyst switch. You have currently 1/1 interface, which is connecting to the physical servers. How are you going to do that? You just access the any switch, you configure the interface, and you enable that some policies like what should be the speed, what should be the CDP, UDP, all these things in a legacy environment. But whereas in ACI, the concept is totally different. ACI concept is totally different. You cannot directly go under the interface, enable these all these things. Obviously, there is an option you can configure through CLI, but in ACI, everything by default. When you purchase any devices, Catalyst switch or any device, Nexus devices, what is the default port configuration, guys? What is the default configuration for the layer 2 devices? By default, you will get the VLAN 1, right? For all the ports. All the ports, some of the models will be ports are up, some model will be port down. By default, for Cisco devices, CDP or LLDP will be enabled, right? By default, auto negotiation will be enabled for the speed synchronization. Duplex will be enabled by default. But in ACI, when you purchase the one box, Nexus 9K box, by default on the interface, everything will be disabled. Everything will be disabled, implicit denied. When you say the implicit deny, it means deny any to any. Okay. This is the default nature of the Cisco ACI. So in ACI, if you want to enable the CDP, LLDP, speed for any particular port, we have to create the policies. Then that policy we have to call under the interface. Then under the interface, that particular interface, we have to associate, okay, I'm configured this policy, CDP, LLDP, LACP, speed policy for this interface. This interface now I want to use for particular leaf switch. So there is a proper flow for the Cisco ACI to configure the access policy. So let's start with the access policy. This is just one-to-one mapping, how you're going to do that. Okay. So let's start with the access policy here. Just give me a second.
We just sorry to interrupt.
Yeah.
In Catalyst device, all ports are in access mode by default.
Yes. Access mode
But
depends
in
on
leaf
again.
switches,
Okay. So in there is a two things.
Yeah.
Major difference you will see in catalyst switches. So if you're having a L2 devices, it's an access port. If it is a layer 3 multi-layer switch, it's going to be routed port even for the catalyst devices also. Okay. But in a Nexus devices, when you purchase that Nexus 7K and 9K devices, all the ports will be routed port. Because this is a multi-layer switch. Okay. All the ports will be routed port. So you have to define that whether you want to use this port as a layer 2 or layer 3. In legacy environment, you have 3 layers: core layers, distribution layers, and access layer. In access layer, all the access port will be used to configure. In here, all the trunk port and routed port used to configure. Here, totally routed port used to configure in the core switches. But in a leaf and spine architecture, spine and leaf, saying that this distribution and access layer, I'm going to combine into the one single box, which we call that leaf switch or TOR switch, top of the rack switch. And this switch will have both the port options, routed port and layer 2 port also. Because this is the switch which is creating the boundary for the your L2 L3 traffic. And spine switch will be totally layer 3. Okay.
Okay.
Let's talk about that policy. So before that, let me draw one paint for you. Okay. This is a one spine switch you have. I'm taking that just simple example. Okay. You have 2 leaf switches. And on the leaf switch, you have 2 servers. 2 servers. Okay. Like this. On the leaf switch, there is a 6 port will be reserved for the spine connectivity. How many ports? 6 ports. You cannot use those 6 ports by default for the fabric, for the host connectivity, host port connectivity. Okay, like this. Is it what will be the spine port? Any spine port you can use for the leaf connectivity. And this will be the minimum 40 gig interface. 40 to 100 gig. 40 to 100 gig. Need to have that. This is the leaf 1, leaf 2. Here we have. Here we have 1/, for example, 4, 1/5, for example, in this case. Okay. We have another interface going like this. 1/4, 1/5, for example. This is the devices I have. Now, our requirement is this interface should be running. Should be running few things. Yeah. First thing is should be belong to the VLAN 100. Speed should be, and this should be the means physical device. Type of the device is your physical, right? Then you have the requirement of speed. Speed should be 1 gig, and then CDP should be off. LLDP should be on, right? Then you have STP should be disabled. LSEP port channeling should be disabled. BPC should be disabled. This is the one requirement for the one interface. Now, how are we gonna achieve that interface configuration? So there is a two types of configuration here. Okay, we create the red line here. But we are going. Could you please guys move?
You have mentioned this for the access port, right?
Sorry.
You have mentioned this requirement is for access port, that is 1/5, 1/4, right?
Not for the access port. This is the access policy. Okay, not the access port. Anything. I'm not specifying port type for now. Okay.
Okay.
This is my requirement. It can be trunk also. It can be access also. It can be routed also. Okay. When you call that this physical domain as an external or the routed domain, that becomes layer 3 external or routed. It means you are creating the layer 3 ports. When you type physical, means your port type is a trunk or access. Okay, but is it necessary to have the physical domain for the any external connectivity? Yes, I will come to that. Okay, there's a two types of configuration in ACI. One is a access in the fabric tab. In the fabric tab, you will see that two options, right? One is, second is, first option is access port, access policy. Second option is fabric policy. When you call the fabric policy, all this fabric policy will be associated to these ports. When you come to the access policy, all this will be southbound interface. Okay, so in order to achieve the configuration of the any host, you have to create the access policies. In access policy, there are multiple types of flow which you have to achieve that. Multiple types of flow which you have to. In an access policy, if I go here, fabric, click on the access policy, you will see that bunch of options are available here. Bunch of options available: pool options, physical option, policy, interface, module, or switches. What are the use of these options? Under the pool, you create the VLAN. Under the physical and external domain, you create that type of the connectivity, whether it's a physical server I have, whether it's I have one router which is connecting to the internet. If it is connecting to the any routing protocol, then it's running the external routed domain. If it is just a simple server, you have to create the physical. Then under the policy, there are a bunch of policies available: global policies, local policy, interface policy, switch policies, all types of policy. Under the policy, what do you have to create? These policies we have to create. Then under the interface, you have to specify this policy going to use this interface. Then this interface will belong to this switch. You have to specify that. Okay. So let's start with that. So under the access policies, so what is the access policies? Access policies to govern the switch port and that provide the connectivity for the layer 2, layer 3 devices. Can be hypervisor, can be layer 4, layer 7 devices, can be layer 3 devices. Okay, there are three types of policies, access policy available. First is a switch policy, second is a interface policy, third is a global policies. Just to remember that in ACI access policy tab, there are three types of policy which is going to be available: access policy, interface policy, global policy. If we see that here, they come under the global policies. These come under the interface policies. These come under the switch policies. 1, 2, 3. 3 types of policies. Okay. Now these policies, in order to make that end-to-end work 1/5 interface on 102 switch, you have to club all these 3 policies: switch policies, interface policies, and global policies, to make that setup up and running in ACI. This is the uh, mandatory way of configuring the Cisco ACI interface. If you do not follow this method, you will not be able to achieve that interface connectivity. Okay. Under the global policy, you have to specify that what type of connectivity you have, what type of VLAN you're going to have, what type of policies you're going to have, whether you have interface speed and all. In the interface profile, you say that on this particular interface, 1/5 interface, I'm going to apply this all the global policy which you have created for me. Then we have specified the interface, but on the switch, we are not saying that on the which switch 1/5 interface. We have to say on this particular switch 1/5 interface will be going to associate. So in ACI, the policy is not locally significant, just to make sure that in ACI, whatever you are going to create, you can reuse for entire fabric. If we are creating one policy, we call that VLAN 10. That VLAN 10, suppose you are using 102 switch to 1/5 interface is using VLAN 10. You can utilize this VLAN 10. If you suppose 1/3 interface, 103 leave, 1/10 interface want to use VLAN 10, do we need to create another VLAN policy? No. We can use the same policy to apply that under the VLAN for this 1/10 interface. This is the beauty of ACI. Everything you can reuse in Cisco ACI. Okay. In a switch policies, what we have to do here is we define that switch profile. Under the switch profile, we associate the interface policies, interface profile. Okay. So let's come with the global policy. We will always start the policy creation with the global policy. This is the first, this is the second, sorry. This is the first step, this is the second step, this is the third step. In the first step, what we create here is VLAN pool, domain, AAEP. These 3 things. What is the flow of this? This one. This is your connectivity. This is the one leaf connecting to this interface. We have to create the VLAN policies, VLAN pools. We have to create the domain. Then we have to associate, if any device come under this domain, they will have the access of this VLAN pool. They can utilize the range of the VLANs. Then for the AAEP, what the AAEP means? This AAEP represents that interconnectivity between the 2 profiles, 2 policies group. If suppose interface policies want to talk to the global policies, how they gonna talk to? They will always be talking through the one client, which we call that AAEP client, AAEP policy, attachable access entry policies. I know for some of you, it may be getting confusing here. So let me draw that one topology for you. So let's take that in a simple way. This is your leaf. This is your server. This is one connectivity I have. I have 1/5 interface on the 102 switches. Now there is a flow. For first flow is global policy. I will create the global policy one. In the global policy, I will say that I have VLAN pool. In the VLAN, I can use 100 to 1000. This is a local, this VLAN pool will be available for all this ACI. It's not for only one connectivity. Okay, not for only 1/5 interface. No, this VLAN pool I'm creating for entire ACI. One of the interface will be using this VLAN pool. Then I will create the connection type, I'm going to say that physical because it's a server connectivity. Okay. Then I will say that AAEP. What is the meaning of AAEP? I'm saying that I am going to install one client for in front of me, which will have the responsibility to make that communication with the interface policies. In the interface policies, I will say that policy. In the policy, I will say that CDP, LLDP, speed, all these things will be available. I will create under the policies. Then I will say that this policy, I will create one group using this policy. We call that policy group. It means bunch of policy. I will do one thing. I have 2-3 interfaces for 1/1, 1/4 interface also. 1/4 interface will be requiring the LLDP of CDP on, right? And speed should be the 10 gig instead of 1 gig. This speed should be the 1 gig. What I will create here, I will create one group saying that I will create one group with the 2 different configuration, 2 different policies. If any interface want to use 10 gig speed CDP off in anything like that, I will be used one particular group to assign that. If any interface want to use 1 gig in speed CDP enable LDP enable something, I will be use one of the group to use that. Okay, that's why collection of policy we call that group, policy group. Then I will create that access policy. Okay, but we call that this is the policy group. This is a policy. Then we have profile. Then we have profile. In the profile, I have to specify interface selector. I'm going to say that 1/5 interface will be using this particular policy group. So from policy, I created one policy group. Then from the policy group, I created one profile. Okay, but so far we have not specified that which switch will use 1/5 interface. So far I'm saying that 1/5 interface, whoever going to use 1/5 interface, it will have this particular policy group associated to it. Whether they are using on the 102, whether they are using 103, if they are going to use this interface policy group and interface selector, all these switches will have the same policies. This is the use case when you have suppose two switches, 1/5 interface, 1/5 interface, they want to use the same policies. So instead of creating two different policy, you can create a single policy saying that 1/5 interface, whoever is going to use on the switch, I will be using this particular policies. Okay, then you have a switch selector. When you have the switch selector, in the switch selector, you have called the profile. Switch profile. In the interface selector, in the interface profile, what is the meaning of interface profile? Is an interface selector. What does switch profile mean? Switch selector. Switch selector. What is the policy? Policy group means it's a policy collector, right? Or it's collecting all the policies. Then we are going to associate this interface profile to the switch profile. In the switch profile, we are going to call that on the which particular switch we are going to use this profile. This is the end-to-end of access policy for your simplest way. Okay, end-to-end policy. Now let's configure that. Before that, let's go into the theoretical part first. In the global policies, what are the VLAN pool? VLAN pool will be always the encapsulation which we are going to use for the end host devices. What is the domain? Domain is a type of connection, whether it's it has physical connectivity, virtual connectivity, layer 3 connectivity. You have to tell ACI what type of connection you are going to associate with this particular interface, this particular ACI. Suppose if you are integrating the VMware infrastructure, right? How your ACI would get to know that this is a VMware infrastructure? It will not get to know that, right? You have to tell manually, this is a virtual environment I'm going to associate to it. Then ACI will understand that, okay, I have to respond to this particular traffic based on the VMware setup. If you're saying that ACI, I'm going to create layer 3 domain for you. It means ACI will be saying that, okay, from using this particular interface, I am going to use this particular protocol, then I have to behave my ASIC label behavior will be changed based on that. Okay. This come to the attachable access profile. It will be used for the grouping the domain into the AAP, and it will also associate your interface policies to interconnect with the domain and the VLAN pools. Okay. Before starting the configuration, can we take like I said, 10-minute break or 5-minute break if you want?
Yes, sure. 10 minutes
Okay.
is fine.
Yes,
Vijay,
sir.
one
Okay.
doubt here. When we are creating the policy,
Mhm.
in policy, suppose we have already policy set up for interface. Like suppose we have configured the bare metal policy on particular interface, but
Mhm.
my another configuration, I need the different interface. In that, I can use that policy if
You
my
can use the
interface is
policy
different.
group. You can use the
Mm-hmm.
policy group, not the interface selector. You can use the policy same policy group.
Yeah, because my interface is different, so I can use that policy, if my
Yes,
configuration is same.
yes, you can use that.
Yeah.
Okay, let's come after like 5 to 6 minutes. Okay. So resume that. Start with this. So where we were. Okay, so let's configure that access. So everyone is back, right?
Yes.
So let's start the configuration here. So from where we are going to start with. So let's start with the okay, yeah. Under the fabric access policies. Under the access policy, there is a multiple options are available. VLANs, multicast address, vSAN, and VXLAN. It means suppose you have one host 1/5 interface. Want to have the VXLAN based communication. You can have the VXLAN based end-to-end native communication. If you want to have the VLAN based communication, you create the VLAN pool, right? Second option is suppose you have the leaf. That leaf is connected to your storage or boot or from some net app device, some kind of fiber channel connectivity it has, right? FC connectivity. Rather than having a Ethernet interface, it has FC interface, which is also possible in ACI. ACI does support SAN. In this case, we call that vSAN because fiber channel does not support the by default VLAN. It has to be vSAN for FC and FCOE. Okay, then that time we use the vSAN concept. But for now, currently we have the interface which is we are using for the like Ethernet connectivity. That's why we are going with the VLAN connectivity. So how we can create that? Right click, create VLAN. I will say that. So if you'll see that there is two types of mode: dynamic mode, static. So there is a two options. When you have VMM domain, VMware integration, hypervisor integration, virtual networking, when you call the virtual networking, that time we use the dynamic allocation. When you have the non-virtual networking, suppose if you have the one physical host want to use, one router want to use the VLAN, that time you use the static allocation. Okay, so I would say that pool for test, I will say the static allocation, and I will say that VLAN range. I will say the VLAN 100 to 1000. There is that options are available like allocation. What is the difference between VLAN mode and allocation mode? VLAN mode and allocation mode is going to be like VLAN is the type of VLAN we are going to create. Then suppose you create that dynamic VLAN 100 to 1000, for example. Can that VLAN be dynamically allocated anywhere? If you select that static, it means it cannot be dynamically allocate that. If you are selecting that static dynamic VLAN 100 to 1000, select dynamic allocation. It means it can say that this VLAN range will be dynamically associate to the EPGs which we are going to associate with the VMM domain. Okay, so I will say that static, always select that inherit means whatever you have configuration in your parents mode, inherit means it will be by default sync with that. How many types of VLAN we have? Two types of dynamic allocation and static allocation. Dynamic allocation we use for the virtual networking. Static allocation we use for the physical networking. Okay, VLAN pool is created now. Now let's create the second option is
VLAN that is static and dynamic. So in both we are giving the pool range, right? So
yes.
how the static allocation will be taking place, and how what is the difference between the both?
Okay.
Because we are giving particular range only.
We have one VLAN. Okay, VLAN pool. In the VLAN pool, we have two types of VLAN. Okay, one is a dynamic. Second, oh, sorry, spelling wrong. Static. Okay, in the both the location we have VLAN pool. Both the range we are going to give that range VLAN range. Okay, 100 to 1000, for example. Here we're going to give that 100 to 1000. Here is a two things available. If you want to use the VMM domain, suppose virtual networking. So Cisco said that virtual networking. Cisco said that you cannot use static VLAN for the virtual networking. You have to use the physical virtual networking dynamic VLAN. In the dynamic VLAN, there is two types of mode. Two types of mode available. Whereas in static, only one mode is available. Here we have dynamic allocation. Here we have static allocation. It means saying that if you are integrating your hypervisor with your Cisco leaf switches, here. So there is a capability I'm going to give you to, if you are creating EPG 10 and associating with this particular EPG with this particular VLAN range, this particular dynamic VLAN, ACI has capability to push that dynamically VLAN for you. You do not have to worry about that APG will use a VLAN 10. If ACI will automatically pick the VLAN from this range. Okay, but if you want to control that VLAN allocation for your dynamic hypervisors, you going to use the static allocation. The difference between the dynamic and static is you are pushing your VLAN to the next hypervisor device outside of ACI leaf switches. That's the difference here. That's why it means from one device to another device, we are sending the VLAN. That's why we call that dynamic VLAN. Here, we are associating this VLAN only to the leaf switches. We are not sending this, pushing this VLAN to the in-host device. Right? If the physical host is connected here, whatever we are going to use this static VLAN here, it won't be visible to here. But in a virtual networking, you are pushing the VLAN towards the next hop device, towards the DBS switch, towards the V switches, hypervisor. Okay, suppose you have one hypervisor here. This is a hypervisor. On the hypervisor, you have one DBS switch, and you're creating one EPG here, EPG 10. Then EPG 10 will be created to the hypervisor if you're going to use the VMM domain. And that particular EPG, what VLAN going to be used, that will be from the dynamic pool. That's the reason if you are using the virtual networking, you cannot use static. Static will not push your static VLAN will not have capability to push your VLAN towards on the hypervisor devices. Allocation mode is totally different. Okay, you can control the allocation for your endpoints, but dynamic means you are pushing the VLAN to the hypervisor, installing the VLAN to the hypervisor from the API to the virtual networking.
Okay,
Is
in
it clear?
pushing also we can select like either the epic will use the range like 101, it will push to hypervisor, and we can also select that epic should use 101 VLAN only, right?
Yes, yes. So
Okay.
it has two more, like saying that APIC can take decision by its own, then you have control to take the decision on your own. Okay,
Okay.
here APIC take decision. Here user take decision. Which one is the best practice? User take decision is the best practice. Because if you have like 10 VMs running right in a virtual networking, and you want to use that particular VLAN for particular VM for particular VLAN only, right? In the APIC dynamic decision, you can get random VLAN. You can get VLAN 500 all, right? It is not under you. But if you are doing the static allocation, you can control that allocation. I'm going to use this particular VM for 501 VLAN only.
Okay, this is the reason for any VM server we don't pass the VLAN. We don't do the VLAN passing configuration on for the EPG binding and like,
Yeah, exactly. You are
because it is
using the dynamic
dynamically
allocation.
allocated. Okay.
Yes. I will be showing you both the options. Okay. But yeah, theoretically is always you should understand that both the options.
Yeah, because for other ports we pass the VLANs, but if the server is VM, then we don't need to do we don't need to pass the VLAN. This is the reason
Yes.
that we
Yeah.
are using
Yeah.
the dynamic allocation.
Exactly. So it's like different customer has different use cases, right? So one question is, suppose currently you are using the dynamic VLAN port. Is it possible to convert the static VLAN? You can do that, but you will lose the entire connectivity. It means your dynamic VLAN which has been pushed here automatically will be removed. So always migration will be the disruptive here. So in initial phase only you have to decide that what option allocation options you have. Okay. Any questions on this before I move forward?
Hello, Vijay.
Rejected.
Hello.
Hey.
Can you please explain when to use VLAN and when to use VXLAN?
Okay. So when you have suppose native VXLAN requirement, or for this is nowadays a very good example is NSX involved. NSX is a Geneva based convention. Okay. It uses Geneva. It means it has a VXLAN capability, and you want to have the end-to-end VXLAN traffic. If you want to have the end-to-end VXLAN traffic, you can use that. You do not want to use the VLAN for your environment. The reason is VLAN has something limited number 4094 something, right? But you do not want to utilize that VLAN. You're saying that I want to totally dedicate my end-to-end networking. It means host to network level. I want to use everything using the VXLAN concept. In this case, you can use that using the NSXT, one of the example. Second example, if your end host, you're purchasing support Dell server, example, HP server or Cisco servers, your server having a capability to run the VXLAN, you can also do that VXLAN based encapsulation for your entire network. And the advantage, disadvantage are two things. I will be covering the VXLAN topic after this today class, I believe, if I cover that. Like what all where we use the VXLAN, what are the use cases of the VXLAN, and what we are getting using the VXLAN, and what all the VXLAN solving the problems in the infrastructure. Now this is the one of the example. Okay. It's not necessary to you have the NSX to run that, but yeah, one of the use cases is that only to have the better mobility in your infrastructure to extend. Suppose you are having the two data center, right? In a two data center, you having a you want to extend that 4,000 also 5,000 VLAN. You want to extend it, but the range VLAN, the range for the VLAN is 4,000, right? How are you going to do that? You might use some translation, and there is some technology called OTB. OTB has a simple limitation called the 256 VLAN. L2 VLAN can be extended across the two sides. In this case, VXLAN is the second use case options to extend the layer 2 connectivity up to the 16 million segment between the two data center, more than two data centers. I come to that. Okay, no worries. Any questions also on the VLAN? If not VLAN, then VXLAN. Yeah. Yes, Pankaj.
No, sir, no question.
VXLAN you will explain us later, right?
Yes, I will be
Yeah, so
and talk. Go. No worries. For the vSAN, we're going to use that when you have fiber channel connectivity. When I say the fiber channel means SAN, storage area network, FCOE, this connectivity when you're going to have in your infrastructure. It can be like your storage. Storage, we call the storage can be this NAS, it can be the iSCSI, this can be the JBoard, it can be NetApp. This is all connectivity when you do that with the Cisco ACI. Only a specific ACI leaf supports the SAN connectivity. Okay, not all the spines, not all the devices. 93.180 supports that FCOE FC interface. Any other than this particular model number, if you want to run the storage in your infrastructure, those hardware will not be compatible. Those hardware will not be supported. Only this particular device has the storage interface or fiber channel interface. Okay, done. Let's come to the second task.
Vijay, that VLAN, like when we want to use VLAN and VXLAN, means it depends. If we want the VXLAN connectivity, then we will use the VXLAN, right?
Yes.
At that place, we can also use the VLAN, right?
Yes, we can use the VLAN.
But like if fiber channel configuration, fiber channel is there, then we cannot use the VLAN. We have to use VSLAN.
Yeah, so there is a two option. If you're using the native fiber channel, then you have to use a vSAN. If you're using the FCOE, then you have to use a vSAN as well as a VLAN both. Okay, what is the fiber channel? FCOE means fiber channel over Ethernet. It means you traffic will be coming from the vSAN, ACI, then ACI will be converting to the VLAN. But if you're having the native fiber channel, then end-to-end vSAN you have to use. Okay. Let's come to the second point, like connectivity type. So VLAN is created. Let's come to the connectivity types. In a connectivity types, let me draw it again. This is a physical domain. I'm explaining you domain one by one, so I do not need to explain again and again to you guys. Okay. Like multiple types of domain. There is any servers, any router connected to your ACI router for routing, whether it's a dynamic routing or static routing, will be always called that external domain or under external domain. Any server common on the physical server. Okay, under this ACI leaf connectivity, we call that physical domain. Any switch which use that fiber channel connectivity storage come that fiber channel domain. When you have the vSAN connectivity, that we call the fiber channel domain. So how many types of VLAN domain we have? Three types of. There might be more if Cisco keep enhancing. So there is like three types majorly. Physical domain, L2, L3 domain, then firewall domain, there's a layer 2 domain. Layer 2 domain, usually we do not use that. But if in case you want to use that, you can use that. Otherwise, it's not necessary. You can use the static binding also. This one, L2 domain. Again, this is the physical server. So switches connected. Suppose if you have switches connected to it of physical or switches. This is the 4 types of domain we're gonna use that. Here, what we use that VLAN pool. Here we use vSAN pool. Here we use the VXLAN pool. Okay, here we use VLAN pool, VXLAN pool. Okay, here we use VLAN, VXLAN pool. Is that understood? Is that understood, right, Steve? Okay, then after the domain creation, we create that AAP. AAP is what? Is to associate the domain. Suppose if anyone, suppose any traffic is coming, entering, you created one tenant, something blah blah, and you integrated this AAP to this. Okay. If 1/1 interface, this is AAP going to associate with interface profile 1/5 interface. If 1/5 interface receive the traffic on the Cisco leaf 102 leaf, saying that on the 105 interface, what all the VLAN it has. Suppose traffic is coming from VLAN 10. Is whom responsibility to check that whether in ACI VLAN 10 is associated to this interface or not. Whether this interface belongs to this particular domain. Traffic will be immediately come to the AAP. AAP will have all the domain information. All the domain will be associated to this AAP. Okay, this AAP. Then once the AAP will have the association with the domain, then the traffic will come to the domain, appropriate domain. Then appropriate domain, suppose coming to this one, it will check the VLAN pool. In the VLAN pool, if VLAN is 10 not available, then traffic won't be moving forward. If VLAN 10 is available, then traffic will be passed. Then it will be sent to your logical configuration. Okay, this is the flow of your general the global policies. This is the global policy flow. Any doubt on this before I move forward? So I will create the physical domain. One is by default, one will be already created. You can use this policy or else you can create it new policy. I will say create that physical policy test. What all the option is coming? There is 2 options coming in the physical policy. VLAN pool and AAP pool. Because physical domain going to have the 2 association, AAP association and VLAN pool association, right? VLAN or VXLAN, whatever you're going to use that. So I will say that AAP is not created. You can create it AAP from here, or else you can use the default AAP, or else you can create it from somewhere else. I will create somewhere else. Okay. VLAN pool, what I've created, I have created this one, physical pool. That security domain I'm not going to use for now. We'll explain later. Testing, right? Now AAP is missing there, right? Saying that I've created this domain with the VLAN association only. Not this association is still pending. What I will do here is I will create this AAP, and from AAP I will call this domain. What domain? I will call this particular physical domain which I have created. Then I will go to where we can create here under the policy, global policy. Here you will see that AAP by default is created one AAP, right? Try to avoid this AAP use because it has infra VLAN associated to it. Try to create new AAP. So question is how many AAP we can create? So one thing here is this recommended way is to have the single AAP for all the domain. Okay, all the domain. But if you have the virtual domain, you can create separate AAP for virtual network. Can we create one AAP for the multiple domain? You can do that, but that's not recommended one. recommended one is one AAEP, one physical domain, one VLAN pool, like this. But that's going to be too much configuration for you. So that's why create single global AAP and use for entire connectivity. You do not need to create multiple AAP for multiple domains. This is done. Make sure that infra VLAN is disabled. Infra VLAN will be enabled when you have the VXLAN end-to-end concept. And also if you are configuring the AAP concept, or sorry, AES concept, but the virtual switches in virtual networking. As of now, I'm not using that. Here is coming that options, which particular domain I want to associate. Saying that physical domain I want to associate, which I physical domain which I have created here, test environment. Then I will say that, okay, we'll say that physical domain associated, the physical domain say that this physical domain has this much range. Anyone using this domain can use this much VLAN range. Submit. Done. AAP is also done. Now, the second option is what we are going to do here is we are going to create the policies. Okay. So I will
Vijay,
go.
1 minute. Yeah, that physical test you have created, no?
Mhm.
Can you go back to that? In that you have given the range also for the
No,
means.
yes, we have
Uh,
associated the VLAN pool, right? Here. So that
okay,
VLAN
the
pool
VLAN.
automatically is reflecting in the range, right? In the AEP.
Okay, means when you have created the domain, you have associated the VLAN pool which you have created before
Yes.
that.
Yes, yes. That's association we have to do, right? Here.
Yeah. Yeah.
Like this. Here I have pool, like pool is like 100 to 100, 100 to 1000. That's why
Yeah.
in
First,
the,
you have created a pool, include that 100
yes,
to 1000, right?
yeah, one, second, then three. Okay. Now we will
Mm.
associate one to two, then second to three. We will
Mm.
associate. Then 3 to 4. 4 is your profile, a policy group. I will associate that. Okay. Now let's come to the fourth option now, which is like this one, interface, interface policies. Okay. In the interface policy, there is 3 steps. Step number 1, policy. Step number 2, policy group. Step number 3 is profiling. This is a manual way. Everything you can do through automation only. Okay. So let's go to the policy. In the policy, you will see that switch policy, interface policies. What policy we have to create? I want to create the interface policy,
Interface.
not the switch policy. Okay. In the switch policy, like COOP, SAN, fabric policy, this like the control plane label policy, you can create it here. But we are not touching that, right? We are just checking that interface policies. We want to configure the interface. There are some default policy will be already created in upcoming version. Okay, here you will see that. So let me create that. I want to create the LLDP, CDP. So it's already created CDP and disable and enable. I will create my own policy. I will say that CDP, sorry, CDP on. In this policy, I will say the administrative on. Alias means for testing or for like some like if you want to create for some product wise purpose, you can give the product. This is for this particular use only, right? And I will create the CDP off. Always create the 2 policies, on and off. Okay, off. So if any policy you want to apply on and on, off, you can choose any of one policies. Then you can have data plane policy. I'm not going to touch the data plane policy. DWDM, I'm not doing any kind of connectivity here. Fiber channel, I don't have any. Firewall, I'm not doing anything for now. L2 connectivity, no, I don't have anything. Link flap, I don't have. Link label. In the link label is a speed, link speed. By default is already like 100 to 1 gig to the 100 gig is already created. Okay, with a different concept. If I show here, this is some of them have auto negotiation is on, 1 gig is speed, physical is auto negotiation, EMI is retained is disabled, everything is there. What I'm going to do, I'm going to create the new policy saying that 1 gig for policy speed I would say 1 gig speed. Okay, auto negotiation, I will keep that on. Speed you have to define here. In ACI, what is the minimum speed it can support? 1 gig or 100 megabit. ACI can support 100 megabit to 100 Gbps. After like new release, they will introduce the 400 gig switches also. Okay, so 100 to 1 gig, 100 Gbps you can select, or you can select the auto negotiation as well. It's already supported. Will say 400 gig. Sorry, not 100. 400 gig is already there. Okay, so I will select that 1 gig for now. Do not touch that. This, if you want to check that, you can do that. I do not have any specific physical media type which going to use that. I will say that I'm going to say auto negotiation. It means whatever going to you insert the physical SFP, I will be saying accepting that. I will be synchronizing that based on that. If you want to be very specific, I want to use only this particular physical interface for this policy of profile, then if you're selecting this and you're not using the same interface, physical interface SFP model, then it will be issue for you. So that's best practice to have the auto negotiation, right?
Vijay, why this speed sort of policies are required? Means why we create the 10G, 1G?
Because by
something?
default ACI auto negotiation is off, so it will not be able to negotiate with your device. It will not be able to communicate with your device with appropriate speed or physical connectivity. Suppose you have one device. Okay, let me explain in more granularly. Suppose you have one box. You have one physical box here, physical, and you have one interface. ACI has implicit deny rule. It means everything is empty. You have to tell ACI your interface having a 1 gig or 10 gig speed, or you do not need to specify even interface speed also. You can say the auto negotiation is on. Okay, you can do that. It's not a big deal. But by default, interface is having a 0 configuration for the layer 2. Layer 2 configuration is 0, or even layer 1 configuration is 0. So that's why you have to tell ACI. For example, I'm going to say that 10 gig. I can say the inherit. Inherit means whatever is enabled on the neighbor side, I'm going to sync with that. But make sure you have the auto negotiation is on. But if auto negotiation is off, then you have to say that particular 10 gig, 5 gig, or 1 gig, or 25 gig something. I can say that 10 gig, keep that auto inherit. It means it will automatically sync with the LLDP with the neighbor device. But you have to enable that auto negotiation like this. I'm not specify speed. Look here, unlike this one. I can auto negotiation off. I want to keep the 1 gig forcefully for security reason. Some of the servers also doesn't support the auto negotiation. That's the reason we disable that auto negotiation, like for the NFBs and all. Okay, it's not required to specify the speed if you have the auto negotiation is on. If it not auto negotiation is on, but still you want to have the like proper speed control, you can do that. Okay, the LLDP.
That's why we asked from the host team to give us proper that which what speed you require, so that we can create a speed policy according to that speed.
Yeah, but if they say that they do not know that, then no need to worry about that. Create the auto negotiation on, keep that inherit speed. But make sure that from their side, auto negotiation also should be on. Both the side of auto negotiation should be on in order to sync the speed of the interface. Which will be through the LLDP or CDP, any of this. Because LLDP always check the parameters of the device physical interface. This parameter is mismatched. Both one side is that auto negotiation is on, other side is auto negotiation is off, and the speed is different. Then your interface will be in error disable mode. Okay. Flow control, I don't want to create. LLDP, you can create that. For LLDP on, I can say that if you see that LLDP is a non-Cisco property. It has two features, receiving and transceiving, RX and TX. If you want to get that unidirectional traffic, you can change that behavior using the RX and TX method here. I don't want to do that. On, off one. See that. Put this here. MACsec, if you want to create, you can create that. MCP means miscabling protocol. It means suppose if just like a root guard in a legacy environment, how you suppose any interface, you have two switches connected here. Two switches back to back. Two switches connected here. If they are sending the STP, they have STP BPDUs, and they are trying to do any kind of STP reelection, then this switch will say that I'm going to disable this. I'm going to send this interface on the error disable mode. So there is no impact in a Cisco ACI to do that in kind of STP traffic. And second option is if suppose you created leaf to leaf interface or spine to spine interface. In this case, MCP will be also in the picture, saying that I won't be allowing you to connect that connectivity. Port will be immediately on the error disable mode. Okay, so that's also best practice. By default is enabled for the leaf and spine connectivity. But if you want to have the same kind of setup for the in-host connectivity, suppose if you are connecting to the legacy environment and you want to have the kind of connectivity enabled, you can do that. But by default, saying that it will be enabled for all the leaf and spine connectivity for the connection. If you say miscabling protocol means any leaf to any leaf, if you want trying to connect that, it will be not working. Any spine to any spine, if you're trying to do that, it won't be working until unless you have the kind of MCP enabled. Suppose, for example, you have two ACI fabric, one, port two. And this port one is leaf switch, want to talk to port two leaf switch. There is a L2 link, right? In this case, MCP, do we need to disable the MCP, enable the MCP? No, because they are two different fabric. Make sure when you have the same cluster, MCP should be disabled. It means that the purpose will be the totally different for this, for L2 migration something. But if MCP is enabled, you cannot do that connectivity. Because AP cluster is one for the multi-port scenario. For multi-site, you can do that. For port channeling, if you want to create the port channel, so you can create that LACP, PAGP, whatever you want to create the policy. For example, LACP active. So you have multiple options. You can create the static mode on LACP, PAGP, MAC pinning, all these options. I will say the active mode. Then there is a control option for it. You want to enable control individual, suspend individual port, graceful convergence, port standby ports. What should the maximum number of the port channel you can use that? I think here in ACI is 32, I believe. If I keep selecting, it should be 32 maximum, not more than that. But minimum should be the one. Okay, you can change that. By default is 60. Like this. If you want to create anything like port channel policies, like if you want to change that LACP behavior, like LACP also does the reelection for the traffic monitoring, traffic sending, you can change the priority also for RX and TX. For port security, you can configure the port security. Like what should be the timeout for the in host, what should be the maximum traffic hold time, and this traffic flow control. Here we have a spanning tree interface. On the spanning tree interface, you can control the BPDUs, whether you want to enable the BPDU guard, BPDU filter. Only two kind of BPDU is supported on the Cisco ACI. So there are multiple BPDU security, like BPDU packets, BPDU guard, filter, root guard, loop guard. These multiple options are available in a BPDU security, but only filter and guard is supported. Filter means one-way traffic will be blocked. Guard means entire outgoing, ingoing for the STP will be blocked. Storm control you can do for the CPU or optimization. You can control the unicast, multicast traffic for a particular port. Suppose you have 1/5 port. On the 1/5 port only, this much packet drop you want to receive, this much broadcast traffic you want to receive. You can create that policies from default. Is policies already there. You can do that manually also. Saying that if packet is crossing this level, it means drop the packet. You can action the perform the like shut down the interface. But dropping the storm will be always preferred over the shutting down the interface. Okay. Then we have the global policy. Suppose this is the interface, this is the global. Under the global, you have the DSCP relay configuration, all this configuration, MCP policy configuration, retention policy configuration, all these things. Okay, saying that in MCP policy, saying that if anything seems like is a looping, port will be disabled. You can change the event action also here. Okay, QS policy you can change from here, but this is not going to touch for now. Okay, policy is created now. Okay, 2-3 policy I have created here. Now let's create the policy group. I will say that I'm going to create the access port for this. Okay, so in the interface profile, leaf interface, in the leaf interface, if you'll see that there are multiple things: profile and policy group and override. So first I will create the policy group, then I will create the profile. Okay, in the policy group, I will say that which interface policy group type you want to create. You want to create BPC interface, you want to create access port, you want to create port channel, you want to create FC, you want to create the FC with the port channel. If you have any breakout port, you can create that. So as of now, I want to create access port. Create access port. I will say that access policy group. Now I will say what attachable access profile you want to associate. So what I will do here is in this access policy group, I will call this interface AAEP. Okay. So if any interface come under this access policy group, a profile will be using the, let me draw the flow first. Access policy group, access profile, switch profile, then profile. So what will be here is this access policy group will be associated to here. It will be associated to the here, and here will be the 1/5 interface, not here. Okay. Here. Then this interface will be associating to the switch profile. On the switch profile, one host will be connected here. Just to understand this flow, guys, okay? This is very important. This host will be connected on the 1/102 switch. On the 102 switch, if traffic is hitting on this 1/5 interface, the switch will immediately transfer to the interface group. Interface group will check the policy group. Under the policy group, what all the policies are applied: CDP policy, LLDP policy, auto negotiation, speed. Then it will check the AEP. In the AEP, what domain it belongs to, what VLAN is allowed for this one. So the first time when packet hit on the leaf switch, this all the things parallelly happen. Leaf switch send your traffic or the L2 messaging to the your profile, interface profile. Then interface profile will check the interface policy group. In the policy group, a lot of policies will be associated. In the policy group, parallelly will have the AEP. Then AEP parallelly will also will check that this physical connectivity, physical domain, and VLAN encapsulation. Then only once this all the connectivity is done, then only packet will be passed through the leaf switch. Okay. So what happen is when a when you, this is the switch, this is the switch. When you have one host connected here, one host connected here. When you first time host 1/5 on the leaf 102, 103, 10/4, for example. If these two hosts want to talk to each other, the first time packet will be initiated by the LLDP. In the LLDP, all the L2 parameter check happen. What will happen here is switch profile, interface profile, then in the interface profile, all the three things, then AAEP. In the AAEP, you got what we're gonna have physical domain, then VLAN encapsulation. This all the layer 2 check will be happen, then only packet will be forming the neighbor. They will say that okay, install in my database and go for the next hop connectivity. If your physical connectivity or access policy is wrong, then nothing, packet won't be going any site in ACI. Is that understood?
Yes.
Okay. This is very important, guys. Okay. That's why I'm going slow here. You need to understand the flow of the ACI here. ACI leaf switches. This is the switch. This is the host connected. Once the packet, once you connect the host, LLDP initiate or CDP initiate, whatever it happened, initiate, this all the parameters check will be happen. Then only ACI say that okay, this host having a perfect connectivity, I'm going to create the local table. Then only endpoint or EPM table, you call that build here. If L2 connectivity is not fine, VLAN mapping is not matching, physical domain is not matching, profiling is not matching, policies are not matching, then L2 will, the L2 connectivity itself will be drop the packet. It will not go for any endpoint learning and all. Okay. So I will associate the AAP, then CDP, link global speed, I will say 1 gig, and port 10 I'm not going to have anything. So I will leave this all the policy. These are the advanced level policies. This is the basic 4 policies you have to start with. And these are the some like advanced level. If you want to check MCP, STP, blah, blah, all these things, you can do that. Okay. But basic policy, these are the mandatories, which you should use that. Then submit it. I created the policy group, call that access port policy group. Now I will use this policy group to create one profile. Okay, so I will create one profile where we, under the policy group, there is on top of that profile. In the profile, I will say that create profile for access port, or for like access port, or you can say that interface profile. In the interface profile, interface selector option is coming. In the interface selector, what all the interface I'm going to use? So I'm going to use 1/5. I will say that 1/5 interface. Which policy group I want to use that? I will say that whatever policy group I have created, I will use for 1/5 interface. Okay. If you have suppose 1/4 interface, similarly, last time someone asked me like, can we use that? Yes. If you have 1/4 interface, can we use same policy group? Yes. If you have the same requirement, you can use that for 1/4 also. That's why we call that one policy can be used multiple times. Okay. So suppose, for example, if in your environment you have two types of interfaces, this is very good example. Yeah. This is the production standard. When I especially design the any infrastructure, I follow 2-3 principles for that. Okay. Access port. Then we're going to have VPC port. Then we're going to have port channel port, non-VPC port channel port. there is, it means I'm going to create three policy group. All these three policy group will be valid for entire ACI. I'm not going to create different policy group for different switch, different devices. I'm going to set one standard for my access policy. I'm going to set my one standard for port channeling. I'm going to standard my BPC. Okay, this is the standard we must follow in the production environment to simplify your infrastructure, right? I'm going to say the speed is 1 gig, 1 to 10 gig, or auto negotiation. I can say that CDP should be off, which is very much recommended. LDP should be on. Okay, CDP always disable in your infrastructure. Then I'm going to say STP storm control. I'm going to use that, for example. This is the basic. This is, I'm going to say the BPC. All the BPC devices will be using these interfaces. All the BPC will belong to the LACP active mode. Okay, then I will have a 10 gig interface minimum. This is the, like, in the port channel, I will say that a port channel, a non-BPC port channel, LACP active. Then I will say that this can be the 10 gig to 25 gig interface. So this kind of policy group you can create here. Create the policies, multiple policies, and using that multiple policies, you can create the multiple policy group. If I try to create another policy group, okay, I created one. Let me access policy group I have created. Let me, before creating the profile, access policy. Let me create the port channel policy group. I will say that port channel policy group. Port channel. This is not the BPC. LACP, for example. I will say that using this AAP, CDP, I'm going to disable it. Always, this is my recommendation. Always disable the CDP unless you have some requirement. LLDP on. Port channel policy, I will say LACP active. Then next, do not mess with this. If you have requirement, then you can do that. Finish that. Then I will get BPC port channel. You can do that, like BPC interface policy group. Okay, then you can AAP. If you want to use AAP for different, you can use that. CDP on. I will say that LACP off, active mode. If you see that same LACP policy, I'm going to use for multiple things. Finish. If you see that three policy group I have created. If you click on here, policy group, in the policy group, one is for the access policy, second is for port channel, third is BPC. If there is any like fiber channel and another thing, you can do that. Okay, but this is what I do especially, and this is your production should also have it. Okay, then using this policy group, I will be creating this interface profile. Suppose 1/5 want to have the access policy, you can utilize this. 1/4 want to use this policy, you can utilize this. Similar kind of things. But what is the prerequisite for this one? You need to have the BPC pairing between the leaf to leaf. What is the prerequisite for this? It can be a single interface with your host. What is the prerequisite for this? You need to have minimum 2 interface to connect that. Okay. So you have two, three designs here. You have two leaves.
Vijay, just to interrupt you. Actually, I'm getting confused in this. Can you tell me means again?
Okay. Let me show that.
And if you can means if you can please just in summary if you can just start with VLAN means I'm getting confused. Actually I'm not basic. If I will not be able to clear, then it will be difficult for me. So
okay,
can you please start VLAN? Yeah.
From VLAN again.
Yeah. Means in summary, I want.
Okay. So when you have this connectivity requirement, okay, when you have this connectivity requirement, so first thing is there is 3-4 criteria which we have to follow. Okay, sorry. This is the traffic, in order to achieve this connectivity, sorry, in order to achieve this connectivity flow, you have to follow the few method in ACI. Okay, first thing is you have to identify what VLAN we are going to use that, what type of connection we're going to have. Then you have to associate this to connectivity profile to the interface policies. Okay, there are 3 types of policy in ACI, in fabric policies, access policies. 3 types of. One is a global policy, Interface policies, switch policies. This is understood, right? Three types of policy in access policy: global policy,
Yes.
interface policy, switch policy. In a global policy, we create the interface of not VLAN pools, physical types, or the connection type, whether it's a L3 out, whether it's a uh, storage, whether it's a physical directly host connect, right? You have to specify that. Then you have to create some sort of policy for this interface, right? What should be the policy under the interface policy? You will say that whether I'm going to create the LLDP, CDP, or is what should be the speed for particular interface. Okay, this is the general policy. It's not particular specific to the any interface. Interface policy is a generic policy. You can use that policy for any interfaces. Okay, for example, this interface needs 1 gig interface. You can create 1 gig policy here and utilize that. This is a generic policy. Then you have access policy group. What is the policy group means? Collection of policies called the policy group. Suppose you created the 10 policies. 10 policy you have created, right? But how are we going to use that policies to interface? How are we going to use that policy, right? What I'm going to do here is I will create the one group which will contain these policies. Okay, if any interface want to use policies, I can use this particular group on that interface itself. Is that clear?
Yes.
So what is here is, if this interface require 4 policies, right? 1 gig CDP on, or suppose MCP should be disabled, blah blah, all these things. So I will create generic policies here. I will create 10 policies. For example, 10 policies I will create. After 10 policies, what I will do is I will create the bunch of policy groups. Saying that if any interface for this interface want to have these 4 policies, or this interface, for example, is a access port. So this is, so leaf 1, leaf 2. So there is three types of connectivity. Okay, this is the BPC port channel. Second is non-BPC port channel. Okay, non-BPC port channel. Third is you have just directly single home access port. For access port, I will say that this policy, all these policies will be always apply for this particular access port. Any BPC port channel is running will be using this policy group. Any port which without BPC will be using this particular port channel policies.
Means we will create different access policies, and in that we will bind different policies, right?
Yes, so we are creating the multiple policy group. Okay, policy group is what? Collection of policies. Okay, let me more simplify policy group. I believe that is creating mess for you. Okay, I have created one policy. This is the policy. Okay, policy interface. Policy. In the policy, let me snip that interface policy details. Just give me a second. Let me more simplify for you. Okay. Okay, this is the policy I have. This is the policy I have. Okay, now this policy is created. Now there is a one switch is there. On this switch, one interface, there are 3 interfaces are there. On this switch, there are 3 interfaces, 1, 2, and 3. And there is a 3 types of interfaces. One is saying that I am only port channel, so I need certain policies for me. I am the BPC port channel. Okay, it means I need certain type of policies for me. Then I am the access port. I need certain type of policies for me. So is it possible to directly associate this policy to this interface? No, in ACI.
No.
But unlike then in legacy environment, how you used to configure that, just go into the interface, associate this command, right? But in a ACI, in order to run this command, you have to create a group. You have to say that I am going to create group for me. Group means I'm going to create the collection of policies. in the saying that this is access policies, this is the BPC policy, this is the port channel policy. In the port, in these three policies, what I will say here is CDP should be here, link label should be here, and LLDP should be here, right? Similarly, for this, I will say the CDP is also need for this. I need port channel policy, right? I need some MCP policies as well. But here, this port channel is saying that I need port channel policies. I need port channel policy. Sorry, just give me a second. Yeah, I need port channel policy as well as I need interface policies. I need some LLDP policy as well. Is that understood?
Yes.
I will create the three policy group, and in each policy group, there are going to be the certain types of policies. Here we're going to be CDP on, speed should be 1 gig, and the LLDP should be off. This is the one of the policy. So all the interface access policies, suppose require this policy, we can use this group, right? If BPC port say that I need minimum 10 gig speed, LSCP should be active, and MCP should be off or on, anything. Then we will use this policy group. Okay, this we call that policy group. Okay, then we have port channeling. Port channel say that I need LSCP active, but I will not be BPC here. I also need LLDP should be on. I need link speed is 25 gig. This is the three types of connectivity you have in your device. So what we are going to do here is you have the interface profile then. Interface profile. Interface profile. In the interface profile, you're going to have multiple types of interfaces. Multiple types of interfaces. Saying that if so in a usually what happens is when you purchase the box in a good design, infrastructure design, when you purchase the box, any leaf and spine switches, you dedicate one interface 1 to 10 will be access port, interface 1 to 10 to 15 is your BPC port, 15 to 20 is your port channel port. This is you dedicate for the any access trunk. Okay, BPC our port channel. This is the leaf. This is how I specify when I design in infrastructure. You reserve the leaf port for a specific range. Okay, 1 to 10, 11 to 15, 16 to 32, for example. Now you create the multiple types of policies here. Okay, multiple types of policies here. In the profile, what you say that I'm going to create all these 1 to 10 port with the access policy group. It means on this all the ports I'm going to associate this policy group. Then I will create another profile for the BPC where we have 11 to 15 port where I'm going to associate this particular profile. Then I will create another profile for the port channel where we're going to have 16 to 32 interface. I will associate this profile to this device. Then I will have the switch profile now. In the switch profile,
1 minute, Vijay. Like if in interface profile means like it is 1/5. If I have assigned this port to
any
some
switch.
Any host or anything, so in that case I need an access policy. Okay, so 1/5 will be called as interface profile, or there is some other name it will have, means
Interface profile is under the interface profile, there is a sub profiles. If you go under this one, okay, I created one group. Okay, just follow the
yeah.
interface the policy group is already created, right? Pause. So if I go to the profile here, in the profile, nothing is created. I will say that interface profile I created. In the interface profile, there is three types of interface profile I can create, or per leaf specific you can create that interface profile. Suppose if you want to create this one profile for one leaf, saying that on the leaf 101, 102, I am going to create 102 profile, and all the any interface want to configure on the 102 going to have the profile under this particular profile. Okay. Second option is global profile. It means any leaf in your infrastructure want to use 1/5 interface can use this particular profile. Okay. Global profile and leaf specific profile. As of now, I'm creating the global profile. It means any leaf, this interface 1/5 interface want to use, it will be always access port profile, access port. Look here. If you associate this interface profile to any leaf, irrespective of whether they are in the same port, different port, or they are in the 101, 201, doesn't matter. They will be always, this port will be always access port. This is usually happen when you have big infrastructure and you want to have the consistent policy for across the site, across the infrastructure. Second option is available here. What I will do here is I will create leaf 102, 103 here. And then I will say that any interface belong to this profile, interface profile 1/4 interface, for example, will be using the VPC, for example. Look here. So there is a two types of profile. Here we are specifying that it's still global policy. We are specifying that this will be, we are going to use these interfaces and these profiles only for the specific switches. We can create multiple leaf switches options like this. But if you want to create the, I do not want to create this, I can use the global policies. So what you can do here is three types of policies. Let me delete all of them. Three profile you can create. One profile is access policy, right? Second profile you can create for port channel. VPC profile. I will say that 1/4 VPC interface profile. Then I will say that this is profile for me. Then I will create the port channel profile also. Similarly, if any port, all the ports from the range of the 15 to 11 to 5 will be going to belong to the VPC profile. Any port between 1 to 10 will be belonging to this particular profile. Okay. Any questions on this? Please mute yourself.
Vijay, you are creating global profile, right? So in that case, we can in that case you are specifying that 1/4 port for all the leaves which will be for VPC.
No, as of now, we are not specifying any switches here. Okay. I'm not specifying any switches here. If you want to use this particular 1/4 for all the switches, then under the switch profile, you have to select this profile. Okay.
Okay.
That's the reason I was saying that.
So this is for this will be applicable for which means 1/4 of which switch.
If you want to use this particular 1/4, particularly one specific leaf switch, you can use that. If you want to 1/4 to be used for all the switches, you can use this BPC policies for all the switches.
Okay, and you have also created the leaf-wise profiles,
yes,
like in
our
environment,
one.
I think. Yeah,
which is
in
recommended
our
one.
environment, it is used. Yeah.
Okay, so if you say that leaf 1012 102, so all the interface, so one switch profile will be associating to the one leaf profile. So all the leaf profile under this interface, whatever we are going to have, will be only applicable for the particular leaf here, 101 102, not for all the leaf. Because sometimes in your migration phase, when you have the migration kind of phase running in your infrastructure, this is the recommended one. When you have leaf based, like you have two leaf, on the two leaf, I'm going to create one dedicated profile for you. All the interface under this particular profile only will be used for particularly leaf. So like you can create multiple profile, and each profile will have its own leaf associated with it. Okay, is that clear?
Yes.
All right, so I hope okay, so till interface profile we have created. Now we have not created the switch profile now, right?
And and in the interface profile, you will keep adding the ports, right? Like one
Yes.
slash one, 1/2. If I'm using, I'm
Yeah.
connecting new host or servers, I can go to the interface
So
profile
when
and
you,
can add a static port in that.
yeah, so when you, okay, so in ACI, once you deploy the ACI, you always not create the policy group and policies, okay? Not the VLAN, not the physical domain. These are the one-time creation for you. Only thing is you just keep adding the interfaces on the profile. That's it. You do not even change the in a switch profile. In the profile, you just keep adding the ports.
Got it.
Okay. So let's create that switch profile now. In the switch profile, we have the switch selector. This is switch profile. The switch profile, we call that create switch profile. I will say that leave 102 to 103. What should be the interface profile I'm going to call? I have multiple interface profile. Look here. I'm going to say that this is the leaf
Yeah.
I'm going to use under this. And which interface? I'm seeing that three interface profile here, right? Which particular profile you want to dedicate for this? I want to dedicate for this profile, right? Or
Yes.
if you want to select all of them will be associated. But if you want to use this one, use this one. So
You have
in
created the switch profile for two switches.
BPC kind of, yeah, you can use that. So like this particular interface profile is associating to this particular leaf profile. If you do not want to use this interface profile, you want to use this profile, you can use this also. For example, I'm going to delete it and re-edit for my case. So I can use like this profile. Sorry. Interface selector, not here. In an interface selector, this one. Then I will select that this profile and BPC profile. That's it. Look here. So rather than associating this one, I have associated two profiles to this. Okay, so all the interface which has all the interface on this particular profile will have the same policy on this particular leaf switches. Suppose this interface have 1/5, right? Access port. So these switches 1/5 interface will act as an access port. Okay. Is that clear? I can walk through it again because I don't want you to get confused here before I move forward for further. So let me give you that one flow for this. Okay. Okay. So this is your policy creation. This is when you first time you do that VLAN pool, domain, associate domain to the AAP, then AAP to the access policy, interface policy to the switch policy. Okay, this is the access policy in complete flow. Okay, this is how you integrate your physical device. This is your physical device 1/1 interface you deploy under the tenant. Under the tenant, when you deploy that, how the mapping works. Under a tenant, you specify the domain and VLAN, right, in a static binding. Then using that static binding, how the flow works in access policies, which I will be discussing then. Okay, no worries. Okay. All right. So
The leaf, the interface profile which we have created, like example that leaf 101 what you have created, in that our interface, sorry, access group is binded, right? Na?
port group, which is we call the access policy group. Okay, not the access group, port group, or the policy group. You can say that policy group. Why we call the policy group? Because it has multiple policies associated.
Policies in it.
Okay, why the interface profile? Because we are going to have the multiple interface to it, and it will be using the consuming the policies from the group. Why the switch profile? Because we are going to have the switch. We are going to select the switch on this particular profile, which will be consuming the interface profile. Okay. So far, is there any confusion on the access policy, right? How you create that? This is like the step, all these things. In a 7 steps, you can do all these access policy creations. First, you create the access policies, physical domain, AAP, interface policies, policy group, profile, then switch profile. That's it. This is the one-time configuration. But if you already have the setup in your infrastructure, you do not want to create the new things for you, policy will be already created. Just always check that policy group will be already created. Only thing is, under the policy profile will be already created for you in your infrastructure. You just have to add the appropriate interface with the appropriate policy group. Okay, in your infrastructure, this is the existing infrastructure. For example, suppose for example I want to use 1/10 interface, right, as a PPC interface 1/10. What are you going to use that? I can, whether that interface will be port channel, BPC, access policy, access port, you have to confirm from the server team, right? For example, I want to use access port. I can use access port policy group. This 1/10 interface on the 1/2 and 3 will be act as a access port, because this profile is already associated to it. You do not need to associate again and again. Okay. Any confusion, any thing you want me to repeat that, I'm ready to do that. Okay, guys, before I move forward for conclusion.
Which I need to confirm that by default there is a policy already there by
Yes.
itself in Epic.
Yep.
So it is standard policies, or like
It is a standard
we need
policies.
to.
So it's up to you. If you like the naming convention, you can use that. If you do not like the naming convention, you do not need to use that. Okay, if you see that system CDP disable and enable, if you like the name, you can do that. It's the same. If I open this, it's not different. Look here. You can use that.
Okay. So we have the standard policy already created in Epic by default.
Yes.
Right.
This is the 6.x version, which is already created, but I think below the 6. Version, I doubt that it's not, because in 3.2, 4.2 is not created by default.
By default, they are not. Okay.
Yeah. Only specific version I think it has.
Okay.
Okay. All right. So if there is no confusion, then I will moving forward for the next topic, which is like logical construct of the Cisco ACI. Okay, this is the physical construct of the Cisco ACI connectivity. This is to achieve this interface up and running and to establish the connectivity. This much you have to do that in ACI. It's a huge lengthy process, but this is what it is. Okay. But if you want to create all these things from the script, from the automation, it will take like 5 minutes, less than 5 minutes to do that, to be honest. This is the that's why we have the automation in the infrastructure. Okay, let's take like 5 minute break and come back again, guys, if you guys are okay.
Yes.
Yes, sir.
Right, guys. Everyone is back.
Yes, 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 sir.
So let's start with the logical construct of the Cisco ACI. Okay, in a Cisco ACI, so far we have checked that access policies flow. Okay, let's talk about the tenant flow. So what all these tenants are and what are the purpose of using these tenants? Let's discuss about that. Okay, so in a ACI logical model, so there is a in a by default legacy model. Let's compare with the legacy first. Okay, in a legacy model, by default, all the ports, when you purchase the Catalyst or Nexus 7 key devices or 5 key devices, by default they're going to be default BDC, right, in a 7K, and you will see the default VRF and management VRF. Two types of VRF you will get that in a Cisco Nexus devices, Nexus 7K devices. Even for the 5K devices, 9K devices also, you will get the default BDC and the default VRF as well as the management VRF. So only management interface will be associated to the management VRF, and all the interface which are available in the switch will be associated to the default VRF, and all the configuration will be under the default BDCs. Okay, what all the differences here? So
Vijay, what is this VDC?
virtual device context, you have not heard about that. So Nexus 7K.
Okay.
When you in journal devices, you create the what VRF, right? Virtual routing forwarding.
Yeah.
But
That.
in Nexus
Yeah.
7K devices, you create the device virtualization feature. Like on a firewall, you create the context, right?
Mm-hmm.
In a Nexus 7K devices, we have feature called that a BDCs, which is virtual device context. It's the same way, looks like a context on a
VRF.
firewall, but
Oh,
it has much more powerful feature than the device context on the firewall. Okay, here we have a tenant. What is the definition of the tenant? What exactly we call that tenant? Okay, just give me a second. So tenant is a logical container. Act is a logical container for the applications where you have the a network and security policy enabled for the particular domain. For example, the meaning is here. Suppose you have the customer and you have this ACI solution. Okay, leaf and spine solution. So you have two customers, and you have one more team here saying that customer one, for example, internal customer, you have external customer, you have your DMG application. Now you have requirement saying that customer saying that I want such an infrastructure where you can segregate me separately. You can provide me the resource separately. I do not want to share with anyone. It means if I am using that particular services, that should be totally isolated for my applications. I don't want to use any other services. For example, internal customer want to use some DNG applications in your infrastructure, database, for example. So that customer is saying that I want to particular services to be used for me. I do not want to share my resource with any other customers. In order to achieve that in Cisco 7K devices, we used to have the BDC call, right? We create the device, but we used to divide that physical device into the virtual context, multiple virtual contexts, and dedicate those configurations separately. But in ACI, we call the Cisco 9K devices, saying that it is nearly to impossible to dedicate my hardware to any of the customer, saying that rather than dedicating my hardware to any customer, I have one feature which has such kind of programmability enabled on the Nexus 9K devices, which can support multi-tenancy option. Multi-tenancy means we can have the multiple segregated network on my devices, and they can consume the same resource, same hardware, same interfaces. Suppose, for example, 1/1 interface, 1/1 interface. You have a database, saying that I just have one database connecting to my virtual environment, and there is three VMs: VM1, VM2, VM3, and each VM want to talk to different customers, right? Like this, like this. So this kind of flexibility ACI provides you, saying that using the same resource, I can segregate the traffic. I can provide you the better security, saying that I will provide you such a design, they will not talk to each other by default. They will not talk to each other by default. This is the, you even using the same interfaces. This is how powerful ACI is. Okay, so you are creating a separate logical container for your customer, for a group, for your visibility. It can be your internal users also. For example, you have 3-4 teams, like for like pre-production team, production team, you have the third party applications, or third party from where they are coming, and this is the your applications where they are hosting. Here we have all the internal teams, here we have all the users or third parties are coming to access your applications. So in order to segregate those kind of traffic, we create that logical container in a ACI. By default, there is a three container which is already available in the Cisco ACI. Okay, what are those? Common, infra, management. What is the common means? All the policies will be here. Suppose, just give me a second. What is the tenant? You understood, right? Any confusion? What is the tenant on this part? Before I move forward to the deep dive on this, tenant is a logical container which has the network and security policies that enables the administrator to control within the domain. Okay, so there are two types of tenant we have. There is a two types of tenant. What is the tenant? Tenant is the logical configuration which you do that after this ACI setup. Tenant has two types of tenant. There we have user tenant and the default tenant. How many user tenant we can create? If I go to the operational tab, dashboard capability dashboard, you will see that how many tenant we can create. 3000 user tenant we can create. How many is already created? This is the default tenant which has been already created. You will see that common, infra, management. If I describe that in a better way, this is the leaf and spines, for example, for you. This is the leaf and spine. Leaf and spine. In the leaf and spine, by default, there will be the three tenants. We call that common tenant. We call that management tenant. We call that infra tenant. Infra tenant means, let me check define that. If I got to call the infra tenant means between the leaf and spine switches, whatever is configuration is done, or from the spine to external world. Suppose you have multi-port, multi-data center, port 1, port 2, IP and devices. All these configuration from here to between leaf and spine, IS, BGP, all these things, and from spine to the another data center connectivity. Will all this done will be under the infra tenant. Why the infra tenant? Because this connectivity will be controlled via the APIC, fully controlled via the APIC, end to end. That's why we call that infra tenant. Okay, second is a management. What is the management? When suppose this is a not by default. If you want to have the outer band management connectivity or in band connectivity for all the devices, you usually configure under the management tenant. It's not necessary to have that, okay, but it's a best practice to have that. Then is a common tenant. What the common tenant means? All the services by default fall under the common tenant. It means any user want to use any, suppose you have two customer and they want to use the same services, you can deploy both of them under the common tenant. They can use the same services. Any service deployed under these tenants can be consumed by the any users within the ACI. Even user tenant can consume. So usually what are the services are those? What are the common services we usually use in the infrastructure? NTP, right? TechX server, DSCP, and some of them syslog, SNMPs. These all the services usually be used in the shared network, shared management. We call that. That's we call that common services in the ACI. That's why we have common tenant. We can use common tenant or we cannot use that common tenant. It's up to us. If suppose you have the one ISP internet and you have 3-4 customer, third party customer and DMG host and some user tenant, and all of them want to have the internet access, they can use the same internet. You can deploy under the common tenant. Okay, what is the user tenant? User tenant is a non-default tenant. Default tenant. You can create up to 3,000 tenants for user tenants. Logical container. And each tenant is going to be independent. Independent logically wise. They can be under the same hardware. They can be under the same leaf also. Leaves. Okay. And where these tenants sit in the ACI, they sit in the inside this leaf and spine. These tenants sit under the leaf and spine, between the leaf and spine.
So, Vijay, how they are separating each other? I mean, how they are isolated from each other?
Okay, so we are creating the multiple. The moment you tap that tenant create, so ACI creates separate logical policies for the entire fabric, saying that this particular tenants have the separate unique resource allocated from my side. I'm not going to allow anyone to talk to this tenant by default. You suppose you have two tenants, tenant one, tenant two. The ACI by default say that you are unique through the programmability of the Nexus 9K devices. This is a logical configuration basis. Okay. And each tenant will have its own configuration flow, unlike the common tenant. Okay. This is the physical construct of the ACI. This is the logical construct of the ACI. Okay. So for example, this one, what is the user tenant? It's defined by the administrator according to the need of the users. Okay. So it is not by default is created. It's based on your need, based on your requirement, you can create the tenants here. Okay. Is your tenant is not a private network, just to make sure that it's not a private network. Private network, we call that when you have your own hardware, dedicated hardware for you. That's we call that private network. Okay, this is not a private network. This is the logical container for your applications, just like the VRF in your legacy environment. You have the same hardware, The moment you enable the VRF, can by default two VRF can talk to each other? Answer is no. You have to do the route leaking on that, right? By default, can two different VLAN can talk to each other? Answer is no, right? So it start with the only from there only. So let me draw here. What is the difference here? When you have two VLANs, when you have two VRFs, sorry, when you have two tenants, there's a two different things. Here, VLAN base, VLAN 10, VLAN 20. What are the use cases of two different VLAN? Guys, what are the use cases of two different VLAN? Why we need two VLAN? Anyone? To segregate the layer 2 network, right?
So that there is a segregation between like VLAN 10 can communicate with 10
Yeah.
only means like.
So this is the layer 2 segregation. Okay. Layer 2 segregation. This is the layer 3 segregation. It means, suppose if you have the two VLAN, they want to talk to each other, you need to have their layer 3 interface to in order to make that communication, right? But what if this you want to have the totally separate dedicated infrastructure, saying that VLAN 10 to this, VLAN 20 to this. By default, if they belong to the same layer 3 domain, they can talk to each other, right? But if you put that two VLAN into the two different layer 3 domain itself, can they talk to each other by default?
No.
VRF always create the virtual RIP table, routing information based table. Okay, so this is the layer 3 based segregation. Now Cisco say that, customer say that, I want this both the segregation in my infrastructure. I want to have my separate VRF, I want to have my separate VLAN, I want to have separate everything for myself. Even I want to have separate tenants, and also make sure that I do not have the overlapping IP address. Suppose if one VRF using 10.1.1, second VRF can also use 10.1.1 in the same hardware. So IP limitation also should be go away. Okay. Then Cisco said that in a legacy environment, Cisco said that no problem. I am going to give you that one option. We call that BDCs. It means in the under the each BDC, you will have separate VLAN, separate VRF, separate everything. Skip setup, sorry. Okay. Under the each tenants, we can have separate. Just give me a second. This is BDC1, this is BDC2. Under the same hardware. BDC1, BDC2. Saying that under the same hardware, under the same 7K or 5K or 9K devices, 7K BDC was 7K properties, okay? 5K and 9K just as default BDC. On the 7K device, saying that if I'm purchasing the modular device, I should have flexibility to run this to segregate my hardware, right? Saying that on the same hardware, you can have your own small infrastructure. Similar same replication happen in the Nexus 9K devices, especially in the ACI. Nexus plain 9K NXOS, that's not possible, right? Why the BDC is removed? Why not BDC on the Nexus 9K ACI? Because BDC has some limitation. In the BDC, we used to, suppose if you have 4 GB RAM, in the 4 GB RAM, we used to divide this 4 GB RAM into 2 GB, 2 GB here. But that was the not good idea, right? That was the not good idea, because if one customer choke that or high utilize that, other customer may impact. Here we are saying that not an issue. I'm going to give you that one programming feature on the Nexus 9K devices where you can have the multiple logical container, logical domain for you itself, for yourself, just like a BTC, where you can have your own layer 2 to layer 4 level setup. But layer 1 will be the common for everyone. You are segregating layer 2 to layer 4. Is that understood?
Yes.
Okay. So each tenants will have its own layer 2 to layer 4 segregation. Okay, not the layer 1. Layer 1 will be still same. Hardware going to be still same for your infrastructure. Okay. Let's talk about the infrastructure tenants. Infrastructure tenant again will be used for the leaf and spine, between leaf and spine connectivity. It won't have much use cases. And also if you have multi-port, multi-site scenario, infrastructure will be coming in the picture. What about the management tenants? Management tenants will be used for the inbound and outbound connectivity. Okay. How you can find out that? So by default, if you go to the tenants, all tenants, you will see all the three tenants: common tenants, infra tenant, management tenant. Okay. And each tenants can have its own way of working. And if I go to the more deep drive here, not here. Just give me a second. Okay, not this. So let me draw it here. Under the each tenant, this is the physical bomb. This is the logical configuration. Okay. Underneath we have leaf and spine. This is like we call them leaf switches. Same leaf switch or different leaf switch also. Okay. It's not always same. We have leaf 102, 103. On top of that, we have tenant X, tenant Y. On this tenant, we can have the one or multiple VRFs and number of VRF. What is the how many? Let's talk about the limitation first. In under the one tenants, how many VRF we can create and number of VRF we can create. There is a certain number, but that number is huge. How many gateway we can create in one tenant and number of gateway we can create? How many ACL we can create in ACI and number of we can create that? How many endpoints we can associate to it? Means how many server we can connect to the per tenant and number? There are certain number for that, but the number is huge. Okay, more than 1,000, 2,000. That's why I'm saying the n number. Okay, and always tenant will be associated with the access policies. Okay, tenant will be always associated with the access policy. Otherwise, if tenant is not associated with the access policies, then how this access policy will be having the communication with the logical construct, logical configuration. Suppose this uh, host having a gateway of 10.1.1.1, which will be available under the tenant, right? Not under the policy. It will always have to pass through the access policy that will go to the under tenant to get that gateway, which I will be talking about. Okay. So talk about here. How many VRF we can create and number of VRF we can create. What is the VRF means? It's a virtual routing forwarding. It creates its own routing information table. The main purpose, initially main purpose of VRF to overcome of with the route IP overlapping, because two different VRF can use its own routing to use the same routing, same IP addresses. But later it has become the trend to use for the different segregation. Okay. Then you have in ACI something called that bridge domain. Bridge domain. Suppose you have one server connected to here, like this. And this server has IP address of the 10.1.1./0, sorry, 1/24 as a gateway. So who will be the gateway of these servers? There is a two option. Either ACI can work as a pure layer 2 or layer 3. ACI has capability to work with the both options, layer 2 as well as a layer 3. Okay. Then we have called that EPGs. What is the EPGs are? Endpoint group. Is a collection of physical and virtual devices. This is we call that endpoint group. Any device which has the NIC card and connected to the our leaf switch and it has MAC address and IP address and the namespace, we call that endpoints. Okay, can be on top of this. It can be any servers, app server, DB server, anything like that. Okay. Sorry. What is the flow of this? Okay. We call that EPG here. On this EPG, we associate the access policies. On EPG, we associate the access policies. Access policies. So when first time traffic hit on the this, it will check what? Access policy, right? In the access policy, it will check the various type of information. It will check the global policy. It will check the interface policy. It will check the interface profile. Three things, right? Then if these all are checked, then traffic will be redirected to the EPG. On the EPG, it will check that again access policies. It will check the physical domain or domain type, connection type, and it will check the VLAN encapsulation, whether this EPG is allowed for this kind of communication or not. Then it will go for the next hop. Bridge domain. What is the bridge domain? It's a boundary for the layer 2 and layer 3. It's a gateway for the in-host device. You can say that. It creates the boundary for the layer 2 and layer 3 for the in-host devices. It acts as a gateway for in-host device. It also known as a privacy gateway, anycast gateway. There are three names for this. Okay, and then it associates with the routing. If two hosts want to talk to each other, they will be always talking through this VRF, through the routing, just like a legacy environment, VLAN 10, VLAN 20. But in legacy environment, we used to create the SBI as a gateway, right? Used to. Interface VLAN 10, IP address, this blah, 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 HSRP, blah, 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 right? Then you used to get that, all these things. But here, everything has a flow. First, traffic will connect to here. Check the access policy is fine. Then access, or under the access policy, you will get that association of the EPGs. Under the EPG, then traffic will hit to the EPG. It will check the gateway for that. If gateway is matching, like saying that 10.1.1.1 is mine, it means it will give the reply saying that it's mine. And it will create the one table. Data plane learning table, you can say that. Data plane learning table. It means all the data plane connectivity traffic will be learning on the bridge domain. Then bridge domain will send your information to the routing saying that I have new range, please install in your table for the routing purpose. So far, any confusion for the flow basis? I will be going in depth for all these things, okay? Just giving you flow just like access policies. Just walking through the tenant and all. Then I will go in depth of the EPG, in depth of the bridge domain, in depth of the VRF, in depth of the tenant. Okay. Any questions so far in the integration of it on this design? Okay.
No.
Cool. This is a logical construct of the ACI design. Now, what is the use and how we can optimize this VRF, what all the options are available in the bridge domain, what all the options, and how we can optimize the EPGs, and how many ways we can create the EPG, how many types of EPG we have. I will be discussing in a tomorrow's session. Okay. So before ending this session, is there any topic or anything you guys want to discuss, or anything, any questions you guys have? Please let me know that. And from here, we are going to continue tomorrow. So please also revise that access policies, and I will be uploading this document to the as well as video on the OneDrive, where I have added all the details. Okay. Yeah, please do not miss the tomorrow class. Tomorrow class is important because we are going to understand that connection between the access policies and the tenants, and how the traffic flow works with that. Okay, that's important one. And please, guys, when you attend the class, I would also highly suggest you to either in your production environment, check the one by one, just taking the read only access, do not click on anywhere, or else you can book that like access DevNet lab for these access policies and all the things. So it will be very easy for you to revise yourself, rather than doing all this theory part. Just go to the lab access, check all the details. It will be very easy for you to understand or revise yourself.